Bismillahirrahmanirrahim. Assalamualaikum dan salam sejahtera. Sebelum sesi webinar ini bermula, diminta semua peserta untuk mengisi link pendaftaran dan menjawab soalan pretest melalui pautan yang telah dipost di ruangan chat. Peserta juga diminta untuk mengisi link keberkesanan khusus dan menjawab soalan post-test melalui pautan yang akan dipost di ruangan chat di akhir sesi webinar ini. Untuk makluman, sijil penyertaan webinar akan diberi setelah peserta menjawab kedua-dua soalan pretest dan post-test. Sijil akan diberi dalam tempoh 14 hari bekerja. Virtual background bagi webinar ini juga telah dipost di ruangan chat untuk digunakan oleh para peserta. Sebagai info tambahan, peserta juga boleh menggunakan hashtag rasmi iaitu hashtag #WLet'sConnect. Kerjasama daripada semua peserta didahului dengan ucapan terima kasih.
Greetings to Technologist Nizam bin Muhammad Nasir, Deputy Director at Politeknik Sultan Idris Shah, Puan Nurul Hanizah binti Hamzah, Engineer, Telecom Engineering and Construction Division at Sapura Energy Berhad, Encik Zarif Nakiuddin bin Abdul Munid, Head of Electrical Engineering Department, Technologist Muhammad At-Tamizi bin Abu Hassan, Head of Program DEP, respective lecturers and fellow students. A very good morning to all participants. Thank you all for finding time and visiting today's webinar. My name is John Allen Samaraltati.
And Nurfara Farzana binti Muhammad Nordali.
And
And
we
we will be the moderators for today's webinar. Bagi memberkati sesi webinar pada hari ini, saya ingin menjemput saudara Fakrullah untuk bacaan doa.
Wa ala alihi wa sahbihi ajma'in. Ya Allah, ya Tuhan kami, dengan nama-Mu yang menyembuhkan segala penyakit, dengan nama-Mu yang mencukupkan segala permintaan, dengan nama-Mu yang memanfaatkan segala dosa, dengan nama-Mu yang tidak dapat dimudaratkan oleh sesuatu, maupun di langit, dan Ia Maha mendengar dan Maha mengetahui. Ya Allah, maka ampunilah segala dosa-dosa keribu bapa kami, para guru dan saudara kami, serta sekian umat di alam ini. Ya Rabbana, sesungguhnya hanya kepadamu kami rafakkan rasa syukur, hanya kepadamu kami menyembah, dan hanya kepadamu kami memohon pertolongan. Maka engkau berkatilah dan lancarkanlah majlis kami ini. Tiadalah sesuatu urusan itu mudah, melainkan engkau jadikannya mudah. Dan engkaulah yang menjadikan kesukaran itu mudah apabila engkau kehendaki. Terangilah hati kami dengan cahaya petunjukmu, sebagaimana engkau terangi bumi ini dengan mataharimu selama-lamanya. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin.
Terima kasih saudara Fakrullah.
Without further ado, I welcome Technologist Nizam bin Muhammad Nasir, Deputy Director Academic, Polytechnic Sultan Idris Shah, to give an opening speech and remarks.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Thank you, Mr. and Mrs. Moderator. Hi and good morning, everyone. A very warm welcome to all of you. Cik Zarif Nakiuddin bin Abdul Munib, the head of Electrical Engineering Department, Cik Muhammad Atamizi bin Abu Hassan, the head of Diploma of Electronic Perhubungan from Politeknik Sultan Idris Shah, and a very warm welcome to our honorable guest for today's webinar, Madam Nurul Hanizah Hamzah. Okay, the engineer from Engineering Construction Division at Sapura Energy Sdn Bhd. And I also been told by the organizer that Puan Nurul Hanizah is an alumni of Politeknik Malaysia from Politeknik Sultan Abdul Halim Muazzam Shah Citra. So thank you for coming, Puan. First of all, I would like to take this opportunity to express my thankfulness to Allah Subhanahu Wa Taala for us to be part of this lovely programs. And on behalf the director of Politeknik Sultan Idris Shah, I would like to convey his message, his salam to everybody. Assalamualaikum warahmatullahi wabarakatuh. He not be with us today because he need to go to another meeting that more important. And also, I've been told by the organizer that this program also been involved with another polytechnics around Malaysia. If I can see here, the names are from PUO and others polytechnics. So, terima kasih kepada students and all lecturers yang terlibat dalam menjayakan program this morning. So it is my pleasure, and I'm very privileged to welcome all of you to this webinar, and also I would like to recognize and acknowledge our guest speaker for today, iaitu Puan Nurul Hanizah Hamzah. We are very lucky and very overjoyed to have you here as a guest speaker. As I mentioned just now, that Puan Hanizah is one of our alumni of Politeknik Malaysia, even though she is not from Politeknik Sultan Idris Shah, but we are very proud of her. I've been told that she is currently working with Sapura Energy Sdn Bhd as a telecommunication engineer, and also been working with the company for the past 8 years. So, ladies and gentlemen, this is the example of an alumni that has brought great glory to the institution, and also be good example for alumni that serve back to our polytechnic. Okay, share her knowledge, share her experience with the youngsters, with the young generation of polytechnics. So by doing so, they inspire, these alumni can inspire so many students to have a clear, concise, the courage to speak the truth, and the importance of being authentic. Oh, lupa nak beritahu. The organizer asked me to convey the speech in English. So I think it is a good platform for us. Okay, in order to improve our English fluency to others, and also encourage all the students also to speak in English. Inshallah, our program today is a second series, a series named Let's Connect webinar that organized by the Department of Electrical Engineering, Politeknik Sultan Idris Shah, where the aims is to give exposure to the students on how the telecommunication works in oil and gas field. With the fourth industrial revolution and technological innovation are significantly shaping the world across sector, with machine taking over the most of the human job. This resulting organization to do more with less, which affect the labor market and forces and workforce. In many cases, machines have come to replace specific tasks, and so do staff, professionals and employees. As a result, machine and digital technology have become a business' biggest asset, rather than its labor force, where in high-scale machinery and computers have replaced low-skilled employees. So in this current technologies, nowadays nak tak nak kita tak boleh avoid dengan the using of machine in our lives. Cuma bezanya apa? Bezanya maybe last time kita mungkin mengingatkan bahawa that machine will replace all the staff, professional, employees. Tapi sebenarnya kita anggap bahawa bila adanya mesin, so all the staff, all the professionals, okay, all the employees need to what? Need to increase their knowledge lah. More clever, okay, more wiser than the machine. Okay, so kita ada a part of machine still can replace human. So in that case, itu sebabnya kita nak minta pelajar-pelajar kita untuk meningkatkan kemahiran, increase your skills, okay, in order to operate the machine lah, to operate the machine yang mungkin kita katakan sebelum ni untuk replace pekerja, tapi sebenarnya tidak. So with all this evolution effective current environment, I do believe that we must prepare our student with the real picture of what is going on into the market. At least we will provide some ideas to our students to prepare themselves before entering the labor market. Saya yakin macam Puan Hanizah, dia dalam oil and gas. So she made many machine lah, which is yang saya kira lebih tinggi penggunaannya, okay, need a better skills in order to handle the machines. So I think we are very grateful to have her with us today. And for the time and effort that she took to share your thought and experience in oil and gas field with the audience. So I personally believe that our fellow students can benefit immediately from the experience of what you share, Puan Haniza. So your enthusiasm, you're contagious, and we hope you will inspire our students lah, in the way that they never dream of. Jadi saya kira program pagi ini memang sangat-sangat bermakna, very meaningful. So to all students, grab this opportunity. Okay, grab this opportunity. Dig as many as you can from Puan Haniza nanti. InsyaAllah Puan Haniza will share with us. Senyum Puan Haniza. Okay, ladies and gentlemen, again on behalf of PSIS Top Management, I hope this program will achieve its objective. And last but not least, once again, I would like to thank our moderator. Okay, I would like to thank our speaker, Puan Haniza, our panelists, and also to Department of Electrical Engineering, Politeknik Sultan, and to all students and to all fellow lecturers from over Malaysia that are willing to participate in this program. And I would like to request permission to leave lah, because after this I have another important meeting, and I hope this program will achieve its objective. So with that, again, thank you to everyone, and I pass it back to the moderator. Silakan. Terima kasih.
Thank you, Technologist Nizam, for the opening speech.
Just a little housekeeping before we start the webinar. Sekiranya tuan-puan dan pelajar-pelajar sekalian mempunyai sebarang soalan, sila type soalan di ruangan Q&A di sebelah kanan bawah paparan Webex. Saya akan bacakan soalan-soalan yang telah di-type itu nanti. Peserta webinar juga boleh bertanya soalan secara langsung kepada penceramah sewaktu sesi Q&A di akhir setiap slot. Berikut merupakan agenda webinar pada hari ini. Rehat selama 15 minit akan diberi sebagai transition di antara slot 1 dan slot 2. Soalan juga boleh ditanya kepada penceramah sewaktu rehat ini.
Now we can begin. Our today's speaker is Puan Haniza. She is an engineer, telecom engineering, in Engineering and Construction Division at Sapura Energy Berhad. Interesting fact, Puan Haniza is an alumni of Polytechnic Malaysia with a diploma in DEP program, where she used to study at Polytechnic Sultan Abdul Halim Muazzam Shah. She also has a bachelor's degree in electronic telecommunication engineering from the University of Malaysia Sarawak. Moving on, I welcome Puan Haniza to deliver her talk.
Thank you to our moderator today, and Assalamualaikum and a very good morning, especially to our Deputy Director Academic for the warm welcome, Head of Departments, lecturers, the organizer, and to all fellow students. So I hope everyone is doing fine mentally and physically. So I would like, first of all, I would like to thank
PUO ni.
for inviting me to this knowledge sharing session. I'm very honored and proud
Apa yang PUO tu?
to serve Polytechnic as one of the product from Polytechnic. Now I will share my screen. Everyone can see my screen now?
Yes, can see.
Okay. Before we start, let me introduce myself. Okay, my name is Nurul Haniza binti Hamzah, and I'm currently working with Sapura Energy, and this year is mark my 8 years with this company. In 2009, I'm graduate from Polytechnic Sultan Abdul Alim Muazzam Shah, Jitra, and after that I pursue my first degree in at University Malaysia Sarawak and graduate on 2014. Right after that, a month after my convocation, I got offer from Sapura Energy and to be as a telecommunication engineer. I think that's it a bit about myself. So today's session, the title was how the telecommunication industry is enabling the digital oil field system. Okay. So for today, we should know the overview of telecommunication system in oil and gas, category of telecommunication system, introduction of backbone communication link, and lastly, telecommunication system for safety. This one will be the second session of this program. So we're moving on. So basically, in telecommunication for oil and gas, there are two platform. This one is the basic of the oil and gas in the world. So there will be two platform. This one is the CPP. CPP means Central Processing Platform. This is the place that all the oil and gas is processed before load up to the onshore for the process at the onshore plants. So this one is the wellhead platform. So at the wellhead, there is maybe a gas or oil platform. It will transport the gas and oil through this pipeline back to the CPP. We also call the CPP is a mother platform, which means that all the process is happen here before going back to the onshore. So CPP is the main platform and facilitate with living quarters. So what is the meaning of main platform? Main platform it means that there is somebody stationed here, such as the operation team, and they also no, CPP also got living quarters for the to facilitate as the CPP. So the operation will station here, and for while we're ahead, there is it is a unmanned platform, which means that nobody living here, and all the condition happen at wellhead will be monitored from CPP as remotely. That's why telecommunication is very important in the oil and gas industry to facilitate this how we call it this current I mean the methodology of the oil and gas telecom in oil and gas. So we move on. So why we need telecommunication offshore platform? For inter-platform connectivity, as I mentioned just now, to connect CPP and wellhead platform. Secondly, to transfer and receive data, which is instrumentation data and telecommunication data. For unmanned platform control and monitoring in real time, it means that we monitor and control from CPP. And then for safety, and after that, we also use for communication within platform. We need to say platform CPP and wellhead and also other platform. For helicopter and nearby vessel. And after that, for emergency communication. Am I too fast? Is it okay?
Yeah, just proceed.
Okay. Okay, what are the systems involved? So there are 3 elements in oil and gas communication. Firstly is external communication. And under external communication, we got digital microwave radio, DMR, wireless broadband radio, very small aperture terminal beside, and also we got fiber optic communication. So this one, external communication, is we can call as a backbone communication link or the main link of the communication for the platform. Second element, we got internal communication, and under internal communication, we have PABX and telephone system, LAN and WAN structure cabling system. This one is for network. Radio for communication between crane and the personnel at the platform. And then we have meteorological and environmental monitoring system. So this one is for weather monitoring. So we want to know the real-time weather at the platform. And then we got VHF AM aeronautical radio. So this one is for chopper landing at the helideck on platform. And after that, we have VHF FM marine radio and global maritime distress safety and security, GMDSS. The third element, we got safety and security. This is I will explain more further in second section. So under safety and security, we have public address and general alarm system, PAGA, CCTV system, marine beacon. This one called Beacon, and it is one of the radar system. And after that, we have GMDSS, VHF AM, EPIRB, and SAT. This one is for live raft communication equipment. For during we use this equipment during abandon the platform during emergency situation. And then lastly, we have non-directional beacon. This one is for chopper landing at the with head of CPP platform. Okay, we're moving on.
Harap maaf, bila minta pelajar untuk bertenang, kita ada sedikit masalah teknikal.
Anyone can hear me?
Yes.
That's one.
Demikianlah.
Sorry for the technical issue, just got disconnected. Okay, we're moving on. Okay, we go for the first external backbone communication, digital microwave radio. So this is the technology for transmitting digital and analog signals such as long distance call, data signal, video images between two locations, meaning to say between two or more platform on a line of sight, on the straight line of radio path. The radio waves are transmitted between the two locations with a directional antenna, and then forming a fixed radio connection between the 2 points. I mean to say it's a point, one antenna and one antenna. And then for offshore DMR link, it's normally used 7 GHz to 8 GHz radio frequency spectrum. And this communication can range more than 60 kilometers if if onshore station is located on a hill or mountain, or for CPP, normally we mounted the antenna at the tower at the platform. And this radio frequency lesson need approval from MCMC department, and it got a yearly operation license fee, meaning to say every year the client or the company need to pay some amount to the MCMC for the license fee. Okay, what the advantages of the DMR system is able to transmit large quantity of data. It can be up to 40 meg throughput than the wireless broadband radio or VSAT. It relatively low cost to deploy a DMR link, and it's operating with licensed band frequency spectrum. Very low possibility to get interference from other DMR link after the deployment, because we pay to the MCMC, so we have a dedicated frequency for this link. So disadvantages of DMR system is a limited to line of sight mode, only with transmission path clearance. If there is any obstruction between the link transmission path, the link will not work. Meaning to say the line of sight of two antenna shall have not obstruction in the middle, or normally at the offshore they got the drilling rigs or vessel, the high vessel. If they block the path, then the link will not work. So there is no attack certificate. There is no attack certified audio equipment available. The audio has to be installed inside flame-proof enclosure. This one is the flame-proof enclosure. Its function that if anything happen inside the box, or maybe spark or fire, it will not going out from this box, this enclosure. It will keep the fire or flame inside the enclosure, and it will not affect other system. So in the market, ODU, the outdoor unit, is not available for hazardous area. And also we can say that ODU is not ODU that we can withstand a high temperature at the platform is not available at the market currently. Okay, this one is sample 3D model of the DMR installation. This one is the antenna. This one is the enclosure with ODU inside it. Okay, we going next. So this one the DMR installation example. This is the antenna. This photo is I took my recent site visit to our yard at Lumut. So this is the antenna. It's mounting at the support, and this one is their enclosure. So there is a cable going here and then going to antenna. Okay, next. So this is the main component of DMR system. Firstly, we have parabolic antenna. So this is antenna that mounted at tower on platform. So we got the clear line of sight. And secondly, we have low loss coaxial cable. This is the low loss coaxial cable. Outdoor unit or transceiver, this one, ODU outdoor unit, that we install in the flame-proof enclosure. Indoor unit, this one, we have indoor unit. Power supply unit. Equipment cabinet. This one is the equipment cabinet. Normally we install at the CPP inside the ECOM room. And lastly, we have flame-proof ESD enclosure. Normally we install at the wellhead platform. If there is no ECOM room at the head platform, because normally the head platform is the unmanned platform, so there is no requirement for the ECOM room to be there. Okay, I hope you until now you can understand me well. Okay, moving on. So second backbone communication is wireless broadband system. This wireless broadband is a technology that provides high-speed wireless internet access or computer networking access over a wide area. It connects one location to another using wireless Ethernet radio. When using high-gain directional antenna, the communication can be ranged more than 60 km with required antenna height and line of sight clearance. This philosophy is same like DMR. It can set up as point-to-point or point-to-multi-point. Meaning to say, point-to-point, one antenna to one antenna, and point-to-point is one antenna to multi-point antenna. It uses 5.8 GHz radio frequency spectrum. It's a license-free frequency band and not required frequency license approval from MCMC. So since it's a free license radio, it is subject to radio interference from time to time. Meaning to say, before we install or before we purchase this system, we need to go to the site to do the site survey and then frequency scanning that and see if available frequency available frequency radio is there, and then we can use as the license-free radio for this system. So what is the advantages? Is a very low equipment power consumption compared with DMR system and VSAT. It's a low cost and easy to set up a link. Can be configured as point-to-point and point-to-multi-point and reduce cost further. It can be deployed anytime, and it got attack certified version is available. Meaning to say it has outdoor type of the outdoor unit and not required the enclosure, flame-proof enclosure. So the disadvantages of wireless broadband is carry lower bandwidth compared with DMR, maybe can up to 16 meg only. It is subject to radio interference from time to time after deployment if there is another new system installed within the same area. We need to say it share the radio frequency.
Nak letak kehadiran pun ada test. Boleh bana dia.
Okay, this is the wireless broadband installation example. So this is the antenna, and then this is the outdoor unit. It is not installed inside the enclosure because in the market there is an outdoor type available. So this is installed on the support at the platform. At the CPP also, it will install at the tower so that it will have a more line of sight clearance for the path link. Okay. So we move on to the topology of the digital microwave radio and wireless broadband. So this is the wellhead side, and then this is the CPP side, and then this is the onshore side at the mainland. So at the CPP at the wellhead, this is the data that need to be transferred or need to be monitored to the CPP, to the operation team at CPP. They will monitor all the current state in real time or the current condition of all the data at the workstation control. At the CPP, there is a panel so that the operation team can see what happened at wellhead because it's an unmanned platform, just like I said just now. So it can transmit process control system, distributed control system. This two is from instrumentation data, CCTV data, telephony, NDB data, and PAGA data. So currently, all data is transferred in Ethernet or IP base, not in analog anymore. And it's going to the LAN switch. The LAN switch is normally we use Cisco switch, and then going to the DMR indoor unit, and then it will transfer through this ODU antenna, and then going to CPP, and the CPP will receive the signal, and it also can control. For example, they can control CCTV. CCTV normally we install in every deck, and then they can monitor. For example, they want to monitor the heli deck, the flare boom, and then it will monitor from here. So after that, all the data it also will go to the onshore client. Normally, client have their own network, such as Petronas network or HES network. Okay, this is just for example. Okay, we move on. So the fourth backbone communication is fiber optic system. So fiber optic cable is a technology that use glass or plastic thread fiber to transmit data. It's made of 100 or more incredibly thin strand of glass or plastic fiber known as optical fiber. So optical fiber are usually used in fiber optic communication, which permits transmission over a long distance and a very high data rates. It can be about 100 meg up to 100 meg bandwidth. And generally, it got two types of fiber optic. First one is single mode fiber optic, and second one is multi-mode fiber optic. So single mode fiber optic is the simplest type of optical fiber, and it's very thin core, about 5 to 10 microns in diameter. All signal travel straight down the middle without bouncing off the edge. This one. So this one, it is straight off. It will straight at the middle of the fiber. Can send information over 100 kilometer. Can be used for IPTV, broadband, internet, and telephone signal as generally carried by single mode fiber optic. Meanwhile, for multi-mode fiber optic, so this is the multi-mode. Each optical fiber core in multi-mode cable is about 10 times bigger than one single mode. It's bigger than the single mode. Light beam can travel through the core by following different paths. In another word, multiple different mode. So it will saturated in the it will saturate inside the multi-mode core glass. And normally it's used to link computer network together. It also can store information only over relatively short distance, not for long distance. Long distance normally we use single mode. Okay, next. So this is the topology fiber optic communication. So we have a driver, a light source, and source to fiber connector, and going to the fiber optic. This one is the fiber optic cable, and then at the receiver we got fiber to detector connector, and then detector, and then going to output circuit. This one should be going to the network. So this is an example for the fiber optic communication backbone. Normally, all the fiber optic communication in offshore use the submarine, subsea fiber optic. And normally also we combine with the power cable. This one is the power. This one we call composite cable, subsea composite cable. It consists of power cable. This one power cable, 3 core power cable, and this one is the optical fiber, the small one, single mode fiber optic. Okay. So advantages of the fiber optic cable: the low cost in the long run, low loss of signal transmission over a long distance is possible. Large data carrying capacity, just like I mentioned just now, can be up to 100 meg. No electromagnetic radiation, and no crosstalk interference between fiber, and it's also a low weight solution. Meanwhile, the disadvantages of fiber optic cable is a very high investment cost, because it's a subsea method, using subsea method, and more difficult and expensive to split the wires than wires cable solution. It means that difficult to splicing. So it's the disadvantages of the fiber optic cable. Okay. The fourth one, can someone mute? Okay, we move on to next main backbone communication link. Very small aperture terminal, or we call it VSAT. So it's a device known as a small private earth station that is used to transmit and receive data signal through a communication satellite. So this method is use satellite and earth station antenna at the CPP or wellhead or vessel. It is used for both broadcast and interactive application of data, voice and video transfer. It also use C-band and Ku band. For C-band, 3.6 to 4.2 GHz for receiving, and 4.8 to 6.4 GHz for transmitting. For Ku band, use 10 to 9 to 12.7 GHz for receiving, and 13.7 to 14.5 GHz. So this frequency is only dedicated for VSAT and satellite use. And then normally at a station or hub site, having installed with a very large 50 to 30 feet VSAT antenna, it will use more space for the antenna. And information is sent up to communication satellite. The satellite which receive the signal will amplify the signal and beam it back to the earth for reception by the remote VSAT. So what are the advantages? It's easy and to remote location where it will be difficult to facilitate wired line communication, and offer flexibility as adding a site can be quick. Is a mobile, can be used for short term or can be set up for emergency communication. It also can set up as a temporary communication. So the disadvantages of VSAT, the transmission quality is subject to weather condition. Stormy weather can cause disruption. It's like our previous communication provider, Astro or etc. During the raining, we will not get the channel, right? And then the service charges depending on the data bandwidth which is subscribed by the user. It's a very high cost to deploy the VSAT, and the licensing, the yearly licensing of the not licensing, sorry, it's a very high cost for leasing the data bandwidth, because we use the satellite. So potentially high leasing cost if use high bandwidth for a small installation or company. It can transmit maybe up to 10 meg or 8 meg, but the leasing cost is very high. For example, during my past 5-year project, I got proposal from one of the service provider. The cost is about 50,000 ringgit for monthly leasing cost. So it's very high cost, and it also is subject to weather condition. If stormy and the weather, it can disrupt the receiving and transmitting data. Okay. So this is the VSAT topology. For example, at the CPP, we install one earth station, and then it want to connect to the onshore. For example, onshore station. So we use satellite for transmitting and receiving the signal. This one got one antenna, and then this one antenna, and use the satellite. Okay. We also use at the rig, the submersible platform, vessel, this one, transportation vessels, cruise, and etc. Okay, we go to the more advanced level. So to deploy all the communication main backbone link, we have design requirement that need to be complied. So for DMR and this one, DMR and wireless broadband, it use same method to calculate the path loss calculation. We normally use path loss 5.0 software to calculate the path loss. Path loss is mean the link between two location. For example, from CPP and to wellhead, we need to calculate the link budget, the path loss. What is the is it okay? Is it acceptable, the link between the two location? So the key design output of DMR link, and this one can be said DMR link and wireless broadband. Firstly, we have link distance, which means distance between wellhead and CPP. And secondly, we need have antenna pointing angle, true azimuth from 2 knots, antenna vertical angle, receive signal, and phase margin of 50 dB or more, link availability of 99.995% or better for all hours per year. And lastly, we need to have bit error rate, BER, of less than 1 times 10 to negative 6. I will explain more in the next slide. So for these three point is the main point that we need to comply to have a good link of DMR and wireless broadband. These three, okay. Bit margin, link availability of 99.995 and bit error rate less than 1 times 10 to negative 6. So this is an example of the path loss calculation that we run on the software. So firstly, we need to provide the coordinate of the two platform. CPP, this side is CPP info, and this side is the wellhead info. We have their latitude, longitude, so this is represent the coordinate of each platform. So this is the true azimuth and vertical angle. Okay, next we have antenna height. You see the antenna height is 69 meter. So it's quite high. It's quite high because it installed on the tower at CPP. Meanwhile, at the wellhead is only 19.35 high antenna height because we installed only on the support. And then the transmitter line length in meter is the cable from the ODU unit to antenna. So it's about 130 meter. But at the wellhead is more shorter, only 5 meter because the ODU is installed at near to antenna. So at CPP, ODU normally installed in the cabinet. So this one is the primary antenna. This one is the secondary antenna. Normally we use DMR. We need to have 2 antenna for this example. We have 2 antenna. Okay, the secondary antenna is right below the first antenna, 57 meter, and at the wellhead it is 15.35. This one maybe it installed at the below deck of this deck. And then its transmitter line length is 120 meter, and then at the wellhead is 5 meter only. Okay, this is the key output that we run on the platform. On the path loss calculation. So I have mentioned earlier that we need to see the phase margin 50 dB or better. So the software we run the calculation, and then after multiple of modulation, we stop at the 16 QAM at 73 meg, and at the phase margin, because the phase margin already received 40 dB or better, so we stop at here. This one is the first antenna, and this one is this one is the run for the both antenna. And then for link availability, we need just I mentioned just now, we need 99.997 or better. So if it stop at the 16 QAM, so the availability is like a perfect one, 99.999%. Okay. So that's all for path loss calculation for DMR and wireless broadband link. Okay, it's used the method to calculate the link. So we go to the next calculation. So for fiber optic attenuation calculation, this calculation we need to do because we need to know the loss of the link of the fiber optic link, so that we should get the very good fiber optic communication link without any big loss or high loss. So this is all the input that we need to provide to do the installation. For first one, attenuation, or we call it loss. This is the reduction in optical power that is passed along the fiber optic cable. Okay, is the loss within the fiber optic cable, loss at the fiber optic cable. Okay, and then secondly, we have total insertion loss. The loss caused by the insertion of a component such as splice or connector. So we know the fiber optic, normally we use we need to have fiber optic patch panel, and then we also use splicing method for fiber optic. So these two two parameter we need to consider inside in our calculation. So fiber optic loss can be categorized by fusion splice or mechanical splice, which range from 0.1 dB to 1.5 dB. So this is their loss for each splice or connector. It depends on the product itself. Connector maybe can be 3 dB, or splicing can be also 3 dB. It depends on the product that we use. We can see at the data sheet. Normally we can have a look at the data sheet and then take the value. Okay. Next one, we have transmit power, mean that source. The output optical power measured in dB from a device capable of converting data into light for FO communication. This is the power source of the fiber optic link, the main source. Okay. For receiver sensitivity, this is the end. This is the end receiving part for the fiber optic link. This is the acceptable optical power in dB of a device to establish good communication. This parameter will be compared from the optical source. This value can be found in the device datasheet and is usually at in a minimum to maximum range. Later I will show how we get this one. And lastly, second last, fiber optic link loss is the loss budget. The amount of power loss in the link, the total amount of the loss in the link, only loss, often used in terms of the maximum amount of the loss that can be tolerated by a given link. It means that loss that acceptable in the given link. Okay. Lastly, reserve optical power is the working margin. The difference in dB between the power budget and the loss budget, such as the excess power margin. Positive value indicate that the receiver will accept the transmit power considering all the losses in the link. Generally, the power budget must be higher than the reserve optical power with recommended figure of 3 dB or more. Meaning that after we calculate the source minus the total loss, and we will have a reserve optical. The balance will be a reserve optical power that need to be more than 3 dB. So this one formula use power budget. Power budget, transmitter power minus receiver sensitivity. fiber optic link loss. This one, the total loss, attenuation loss, loss at cable, insertion loss, loss at splicing and connector. Next, reserve optical power, power budget. This is the source of power minus fiber optic loss. This one is total loss here minus the power budget that we project from the transmitting link. And this is the fiber optic link loss budget. Is the reserve optical power. The amount of power loss in link, often used in terms of maximum amount of loss that can be tolerated by a given link. This one I mentioned just now is should be need to be more than 3 dB. So if it more than 3 dB, so we will accept the budget, the calculation. Meaning to say the link is in good condition. So this is the example of the calculation. It's simple, don't worry. So let me explain the cable board diagram. So this is the central processing platform, CPP. Okay, this area is CPP. Okay, CPP. This one, to link, this one is the subsea cable, fiber optic cable. And then it going to the wellhead platform. So this part is the wellhead. So for example, we can use this one, the transmitting, and then this one at wellhead it will be receiving the data. Okay. So what are the parameter? The parameter, first one we need to have a transceiver. Basically transceiver, this is like a device to give the power source of the link, and normally it installed at the Cisco switch at here, this one switch, can you see here? And then the transceiver at the end side, it will be as a receiver sensitivity at the wellhead side. Okay, at here, this one, transceiver at CPP, and then receiver at wellhead. Both are switch, network switch. Maybe we can say as a Cisco switch. Okay, and then we have fiber optic cable loss at the cable. Okay, for each kilometer, the loss is 0.4 dB. Okay. This one, each 1 kilometer, it will lose about around 0.4 dB. This one cable, this one is also a top side cable. This one top side cable, this one is subsea cable. Okay. Other parameter is splice loss. Splice loss is a loss at splicing. Okay, the parameter is 0.3 dB per slice. So one slice will be 0.3 dB loss happen there. And after that, we have connector loss. Typically, we have 0.3 dB. Sorry, this one as per connector. Okay, this one I got wrong. 0.3 dB per connector. So each one connector we have 0.3 dB loss. So for this example, the subsea single mode fiber optic length, okay, this one fiber optic, okay, this one is around 8.032 kilometer. This one, the length is 8 kilometer. Okay, topside single mode fiber optic. This one topside is mean the platform single mode fiber optic length is around 60 meter. Okay, this one at the wellhead. Okay, this one is around 60 meter length. 60 meter length. And then at the CPP around 160 meter. This one 160 meter. The length, the cable topside fiber optic cable length. So next we have total connector. We have 12 here. So how we count the connector? Normally connector is at the fiber optic patch panel. So total connector, here, okay, this one. The circle one. So for this example, we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one will be, we got connector connection. This one connector, okay. And then lastly, the parameter is total splicing. Splicing, we splice two fiber optic cable directly splicing. So where the splicing happen? So normally it's at the fiber optic patch panel. So this one, 1, 2, 3, 4, 5, 6. So in total we got 6 splicing. Okay. Okay, we move on to the calculation. So for power budget, we need to take the power source of the transceiver. Just like I said earlier, transceiver is the first link, is the power source for the link. Okay, here we take the -1 minus -19. -9 to minus -19. Okay. Transceiver and receiver need to take the launch power -1 and then receiver sensitivity -19. Okay, and then -1 minus -19, we will get power budget of 18 dB. So at here, the power source is, we project 18 dB here. Okay, we project 18 dB at this switch, and then for total loss of the link, we need to calculate each of these connectors, splicing, topside cable, fiber optic, and subsea single mode fiber optic link. So how we get this one? 0.4. 0.4 is the loss at the cable. Okay, this one 0.4. 0.4 times 2, 8.032 kilometer. Okay, this one is loss at subsea fiber optic link. Sorry, fiber optic cable, and then times with 0.4 times 006. This is represent topside single mode at wellhead, and then times with 0.4 times 0.16. So this is represent CPP topside. Okay, 160 meter convert to kilometer, so we get 0.16, and then times with 0.4 the parameter. Okay, and then plus with 0.3 times 6. 0.3, how we get this one? This one is the loss at splice loss. Okay, times with total of splice, and then plus with 0.3 times 12. 12 is the total connector. Okay, after we calculate this one, we got the loss around 8.7 dB. This is the total loss of the link. So the loss, we got the power budget 18. We minus with the total loss. So we have the budget. Okay, the budget from the first transceiver, power source, and then we minus with the total loss 8.7. So we got 9.3 dB. So this will be our reserve optical fiber optic. So what's the value that we need to what the value that is acceptable for the link? Okay. Sorry. So as I mentioned, it should be more than 3 dB. So after the calculation, we got 9.3 dB. So the link is will be working fine and is in good condition. Okay. Everyone okay? Everyone okay? I think it's very straightforward, right? Straightforward calculation. Okay, I think this is the calculation for the design under design requirement. Normally we need to do the calculation before purchase the system or install the system. Okay. Before I end my short one, let's watch some video. This video is example of the main backbone communication link that deploy under ONGC. ONGC is the one of client from India. So they made a video to show their system backbone communication that is like somehow we can call as a big project for main communication backbone. Okay, let's watch.
Kita telah sampai ke sesi Q&A. Peserta boleh bertanyakan soalan di ruangan chat. Maaf, ada segala kesulitan. Puan Haliza, kami akan sharekan video sebentar lagi.
Okay.
Puan okey ke? Kalau kami sharekan video?
Okay. Boleh.
Okey, Puan.
I hope Mr. Johnson likes this SEMrush data.
Just explain it to him like he's a child.
Anyways, this is BLK2. Confirm Lima Hotel taken off for BLK2. Act 14 BLK2.
Lines such as these on the radio form the backbone of communication ever since ONGC ventured offshore. Over the years, for coordination from offshore to base, between offshore installations, with the pilots maneuvering the sorties, radio communication rules the roost. Today, communication, which earlier was restricted mainly to voice mode, has since undergone a sea change, and ONGC has been at the forefront of embracing the latest technology in enhancing the communication and IT systems. These communication and IT systems form the backbone that gives the oil soldier in an ONGCian the confidence to execute the assignment on hand without ever feeling the seclusion of the seas. They are the edifice on which the superstructure of all operations thrive. On offshore, they are critical as they nullify the barriers over distances in almost all situations. It is only with the aid of these telecommunication systems that ONGC is able to run its operations over thousands of square kilometers of marine waters. Platforms, drilling rigs, vessels, choppers, and other installations depend heavily on their communication infrastructure. The objective? To establish clarity of purpose and coordination of efforts in the pursuit to produce the all-important hydrocarbons. As the demand for voice and data transmission and its quality evolved over a period of time, banking on the good old radio communication alone proved inadequate. HF and VHF served us well for some length of time, but they could only handle voice data. For ONGC, no large telecom service provider could be entrusted with the data transmission services, where data security is of paramount importance. Thus, ONGC decided to address its requirement through satellite communication. INSAT series satellites were hired, and communication started with 18 MHz bandwidth in the C-band during the early 80s. This too got overloaded over a period of time, as the traffic of data and data-based applications like SAP, Internet, Intranet, emails increased manifold, resulting in slow response time. To address this and to increase the bandwidth for speeding up the communications, and also as a robust fallback system, the KU-band VSAT terminals were set up on the installations and the vessels in the year 2011. These systems are still serving resolutely. However, due to ever-increasing need for electronic data transmission, the C-band and the KU-band systems have started getting overloaded. Due to low bandwidth, latency or time lag was high, and communication was transpiring at a slow rate. The need for a solution was catching up. Video conferencing had emerged as one effective way to have real-time interactions between the onshore control center and offices and the offshore locations in real time. Decision-making had taken a turnaround with video conferencing. However, bandwidth continued to pose a challenge. To meet this objective of regular video conferencing and also to speed up the data flow, Infocom engineers got their act together on a war footing. With intense homework and diligence, a contract was entered into with Messrs. Ceragon Networks. The project cost 11.48 crore rupees. This is to provide microwave-based communication network, or the microwave backbone from onshore to offshore.
So far, our offshore communication was dependent on satellite communication with very limited bandwidth availability. With the commissioning of this project, we have been able to improve our bandwidth availability manifold, from the existing 72 Mbps to 450 Mbps.
In Phase 1, the network links up Vasudhara Bhavan to Uran, Uran to Neelam, B193, BPB, BPA and Neelam Hira, with a 125-meter tower at Dronagiri Hills at Uran at 80 meters above mean sea level.
ONGC is producing 75% of its oil and gas production from offshore. the role of offshore communication, especially data communication, is very, very important. I thank my colleague, Director Technology and Field Services, to take a lead on that and congratulate the entire team of Infocom.
Phase 2 will encompass the Mumbai High asset. It has a network monitoring system for real-time monitoring of the primary network at Vasudhara Bhavan, followed by standby facilities at Uran.
I am extremely happy and delighted that high-capacity radio connectivity is available to offshore with the persistent efforts of corporate Infocom as well as Mumbai Infocom. We at Neelam and Hira Asset look forward for benefiting from this technology, which is beneficial for all ONGCians in general and more particularly to the Western Offshore.
It is a proud moment for Basin and Satellite Asset to see that microwave backbone project has successfully been completed and commissioned. With the commissioning of backbone project, we are likely to have a better data connectivity from offshore to onshore.
I am very happy to note that microwave-based communication system has been implemented in Basin Satellite as well as Neelam Hira Asset of Western Offshore units. With this kind of benefits and with this kind of base, this will be shortly implemented in MHSAT also, so that we can also reap the benefit of this.
With this microwave link, the miles and knots have shrunk between the base and the offshore fields. A technical snag in operations offshore or any other issue can actually be evaluated by the expert sitting on the mainland without any barrier of distance. Group interactions can also happen at ease over this link.
This high capacity, high spectral efficient and carrier grade of microwave link extending right from the onshore Uran to offshore satellite field is capable of providing all multiple IT services of today, including all IT services and services of tomorrow, meeting the requirement of distal oil field, condition monitoring and surveillance and other video intensive applications. This high capacity microwave link is capable of providing 450 megahertz. This was possible using the XPIC technology and using 1024 QAM.
Every communication system from the past up to the latest have been dedicated to ONGC from Uran. I'm proud to have this state-of-the-art communication facility at Uran.
A feeling of oneness pervades across the offshore. Problems and solutions are shared across the microwaves. Distances are no more an impediment.
This project will enable us to monitor health of our critical equipment which are deployed in our offshore operations. CCTV enabled connectivity to base. This is a commendable initiative by our Infocom team, and for this initiative I would like to compliment each and every member of the Infocom team.
Welcome to the inauguration of the microwave backbone for Western Offshore.
You can use Monday.com to boost your team's efficiency. And I'm going to show you how in 40 seconds. First up, let's integrate all the different tools used by your team.
Thank you for your kind attention. Now I'm happy to answer any question that you might have.
Kita telah sampai ke sesi Q&A. Peserta boleh bertanyakan soalan di ruangan chat atau bertanya secara langsung dengan membuka button unmute anda.
Hello, Puan Haniza. I got two questions for you right now. So the first one is, Can you please explain more about the ATEX certification? And the second one is ATEX certification applied for all communications equipments or only for oil and gas, the oil and gas field?
Hi, very good question. ATEX certified is the certified product that it's certified to be used at the very high hazardous area. Normally at platform, we safety department will assign the area which is in zone 1, zone 2, zone 0, and the stringent one is the zone 1, which is very extreme weather condition and very high temperature. So after they assign the platform, normally during my past project, all platform assigned by zone 2. Zone 2 meaning to say it need to be up to 70 degree 70 degree meaning to say the product need to can sustain up to 70 degree temperature. So for telecom equipment, not all telecom equipment is available in extremely condition. I mean the product not available in the market. So in order to install the product itself on the platform, we need to have the enclosure, the explosion proof enclosure, and then we install inside that, and after that we will comply the zone 2 requirement of the platform. For example, in the market we got CCTV we ATEX certified, but wireless broadband, just I show in the slide. And then we got the telephone, explosion proof telephone, and then we have a radar beacon. This one I will explain more further on section 2 and show the product that we ATEX certified certification. Very good question. For I want to add for this ATEX certified, there is one provider that can normally we need to enroll the class to get the certified to be a certifier of the ATEX, and then they will show you what's the product, what need to be considered inside our design. There's a level of the certifier, and I have already enrolled only one class that basic of the ATEX certification. So I would like to I want to expose student to learn about this ATEX, and then you can be a certifier or inspector to inspect this product during your in your future work. Okay.
Thank you.
Okay, Farhaniza, I got a question for you. So the question is cellular communication feasible to be operated at the platforms?
Cellular communication is
feasible to be operated at the platforms.
Cellular means your mobile phone. Okay. During we before we go to the platform, we cannot carry our mobile phone because it is a very high power. Normally at the platform, we only allow VHF hand portable walkie-talkie with 1 GB power only. So that means no cellular telephone is allowed on the platform.
Thank you, Fain, for the sharing. Para pelajar, jika ada sebarang soalan boleh bertanyakan di ruangan chat ataupun boleh tanya menggunakan button unmute.
Okay, so for my next question is, as a telecom engineer or technician at Sapura, does the design of the communication network at the platforms only involve design and planning parts, or also involve the installation and deployment of the network?
For my scope of work, I'm doing the design. And then firstly, I'm doing the design based on the company or client requirement. And then after that, the client will approve my drawings and my proposal of the network, such as maybe, for example, I suggest to deploy a DMR link, and then I send to client to approve my design. And then after company client approve, and then we will float the proposal to the vendor. So meaning to say, bidder from the vendor will give their proposal to us to review, and then we select the best solution among the vendor, and then after that, after the final evaluation of the vendor, we will submit to the client, and then the client will see this vendor, first vendor, second vendor, or third vendor, and then after that approve the vendor, and then the vendor will come in. We come in into our project, and then they will give the solution, and then they will supply the product. So for example, for the MR, antenna, the audio, the complete solution, and then during concurrently, I send my drawing to the fabrication yard at for Sapura, the yard at the Lumut. So this is the place that we construct a platform there, and then they will do, and then they will do the review again of my design. For example, I design the support of the antenna, the audio, and then fabrication team will review the design, the drawing, and then they will do maybe they will update the drawing as per site requirement. I mean, meaning to say they will upgrade or update the drawing, and then send again to the client for approval. After that, after the purchase order already done, the stage of purchase order already done, and then I will go to the vendor premise to witness the inspection, the testing of the product. So vendor will perform a testing of the DMR system at their premise, and then I will witness, the client will witness, the inspector, the AirTag inspector certifier will witness the testing and inspection. After all approved, and then vendor will send the product, the solution, the system solution to the fabrication yard at Lumut. And then after that, fabrication team will install the DMR antenna audio at site, and then they will call the vendor. This arrangement we call vendor call out. So vendor will give the support to advise vendor how to install, how to maybe, because not all fabrication team is familiar with telecom equipment. So they will call out the vendor, and then vendor will go to the yard to assist for the assist and then commissioning of their system there. And then after all done at onshore, the platform will sail away to their site, to their field. Okay. For example, the field at Sarawak, at oil field, okay, oil and gas field, Sarawak or Kelantan. My recent project is at the Kelantan. I done 3 platform concurrently, and then after sail away to Kelantan, and then platform will be installed by the installation team. Normally is the they will open bid for the installation team. I mean the others team will install the platform and on the jacket at platform, and then after that, after they install the platform at site, there will be a window that we call offshore commissioning window. During that time, we need to settle down all the equipment. We need to power up the equipment at offshore. So another round, we will call vendor to assist for the commissioning. So vendor will go to the platform and then perform the commissioning, witnessed by our offshore operation team, offshore client. So they witness and they will test they will test the link from CPP to wellhead, and then they will run the test about 48 hours to see the link was okay or not. So after 48 hours, and then they will approve the link, and then they will close the commissioning for the link. So to answer your question, my site will be designed, and then after that it will installed by the fabrication team, and then after that at the offshore, vendor will do the commissioning and testing for the link. Very good question.
Okay, thank you.
Okay, so Puan Haniza, I've got 2 questions for you. Is that okay for you?
Sure, no problem.
Okay, so the first one is, can you please explain in detail about the subsea fiber optic communication used in oil and gas?
Second question?
And the second question is, for the installation of fiber optic network, will it be done by Sapura team or other contractors?
Okay, very good question. It should let you understand the philosophy of the fiber optic. So the first question, explain more detail on subsea. Okay, I got a project in so to answer your question, I got a project in 19 to 20 that need to deploy a fiber optic connection between CPP and wellhead at Kelantan. So it is a split scope of demarcation. Mean to say, I have my own scope, and then the other contractor have their own scope. So between the 2 scope, we have the interface scope. So at my site, I will run the top set cable on the platform, and then going to the fiber optic junction box at the below deck. The below deck, I mean to say, the cellar deck is located at the 3rd deck. The below deck, there is a JB there to split the cable. So like I mentioned earlier, cable that submarine cable is combined, is a composite cable, combined power cable. You hear me? I think someone
can hear you.
Yes, you can.
unmute me. Okay. At the cellar deck, this it is located at the below deck, the lowest deck on the platform. There is one JB. We call a splitter JB. Because of the composite cable is a composite cable. It consists of power cable and fiber optic cable. Then it will need a splitter JB to split the cable. So we need to separate the JB because it's the power and the data. Okay. So that no interference happen there. So at the JB, we got two JB that mounted together. One is the power and then one is the fiber optic. So after that, it will go straight away down the subsea cable. So the subsea cable normally there is another contractor that we lay the cable using the vessel. Using the vessel to lay the subsea cable. So my scope is only at the interface at the splitter cable only. So the subsea cable will be installed by other contractor, and then after that going to the CPP platform. At the scope will be split at the splitter box. So the other contractor will stop work at there, and then I will continue my side at the splitter JB, and then continue lay the fiber optic cable on the top side at CPP. So that's the maybe example of the fiber optic communication. So the second one is what's the question just now?
The question is for the installation of fiber optic network, will it be done by Sapura team or other contractors?
Okay, that's one I just mentioned just now. Is the normally is other contractor. It depends on the project. Maybe Sapura also got the expertise to lay down the cable. But it depends on the project and client requirement. Somehow they will invite other contractor to perform the installation. Very good question. It means that you will understand the communication link for fiber optic. Okay.
Thank you, Puan Haniza. Para pelajar ada sebarang soalan nak tanya, boleh tanyakan di ruangan chat ataupun boleh unmute button anda.
Okey. Assalamualaikum Puan Haniza. Saya nak bertanya on behalf of student saya. Okey. Untuk Sapura Energy ni, peluang pekerjaan untuk diploma holder tu macam mana? Boleh Puan Haniza terangkan sikit? Terima kasih Puan Haniza.
Untuk diploma holder, sorry, you hear me? Okay. Dengar tak?
Okey. Dengar dah.
Okay, dengar dah. Okay, saya cadangkan untuk pelajar diploma boleh pursue untuk ambil kelas untuk CADing, AutoCAD. Because sebab diploma lebih kepada practical kan. I encourage to have a class, enroll class AutoCAD class, and then kita juga gunakan 3D model like Aviva software you can apa ni, kita boleh tengok, kita boleh explore lah 3D model. So yang itu memang biasanya diploma stage boleh apply untuk tu. Itu pun itu antara kerja-kerja yang agak lumayan dia punya salary base, sebab dia praktikal kan, dia memang perlukan technical expertise. Macam saya just engineer tapi saya tak boleh buat coding. So saya kena minta our draftman untuk lukiskan drawing saya lah. Tapi kalau untuk engineering, untuk design kena ada degree, at least first degree. Macam tu lah. Boleh explore lah macam AutoCAD, Viva 3D model, untuk diploma stage. And then EdTech certification pun boleh. Macam saya cakap tadi, boleh enroll EdTech lepas graduate, kita boleh pergi enroll, tapi kelas tu agak mahal sedikit sebab memang gaji dia pun lumayan. So dia punya nak masuk kelas pun mahal. Macam saya ada first class je yang baru saya ambil lah. So lepas tu kita boleh jadi inspector. Itu memang untuk level diploma. Saya harap itu boleh membantu pelajar-pelajar diploma. Kalau saya rasa sekarang ni coding ada ke syllabus dekat Politeknik? Ada kan AutoCAD?
Ada pun.
Ada pun. Itu boleh study and then boleh practice more. And then boleh start untuk minta kerja sebagai draftman ataupun drafter. Ia guna pakai juga kepada consultant ya. Normally dekat Sapura kita juga buat engineering sendiri, and then kita juga ada minta consultant yang buatkan design. So boleh juga minta kerja untuk drafter ni dekat consultant institution lah. Kalau pursue degree pun okey juga, lagi bagus lah. And then lepas pursue degree, and then boleh boleh apply untuk professional engineer. Yang tu saya pun tengah sebab projek ada banyak, so saya tak sempat nak siapkan saya punya modul lah, saya punya report untuk pursue my professional engineer certification lah, IR.
Thank you Puan Haliza. Para pelajar ada sebarang soalan lagi untuk bertanya? Sebagai makluman, link untuk pendaftaran dan soalan pretest telah di-share di ruangan chat. Mohon semua peserta yang masih belum mendaftar dan menjawab untuk segera melengkapkan link tersebut.
Hi, madam. Can you hear me?
Hi.
Okay, madam, I have a question that what are the most demanding engineers for oil and gas industry? Is it electronic engineer, chemical engineer, or environmental engineer, or so on?
Hi, thank you for the question. In oil and gas, we have a structure engineer doing the structure of the platform, instrumentation engineer doing the system. This one under electronic, we can apply for instrumentation engineer. The engineer will do the design for the instrumentation such as valve, fire and gas system. And then we have electrical engineer. We also have process engineer. We also have piping engineer for pipeline. And then we have a safety engineer. I miss. And then after that, and the last one is we have a project engineer that will manage the project. So for me, the most demanding engineer is electrical engineer. But for telecom we can say is a special one, because not everyone know for telecom, and telecom engineer is not many in the market. To answer your question is electrical engineer. He or she can not only at the oil and gas, but and also can apply exposed to the other industry as well. MRT, plant for which one plant tadi power plant. That's one that's the most demanding electrical and easy to get job. But but to complete the complete solution of the platform, we need all of the engineer there.
Okay, thank you, madam.
Assalamualaikum.
Waalaikumsalam.
Boleh saya bertanya, saya Puan Ruslina daripada Jabatan Juruteraan Elektrik Politeknik Ibu Umar.
Ya, Puan.
Berkaitan dengan skop kerja lah. Macam tadi saya tengok ada yang telecommunication ni banyak fiber, banyak reset. Kemudian dari segi installation, dari segi maintenance tu saya dengar tadi lebih kepada vendor kan? Betul tak?
Okay, untuk maintenance, operation team macam kat klien ada operation team kan, dia boleh juga, dia ada operation team ni memang buat maintenance, tapi kalau ada macam masalah besar, dia akan engage vendor juga untuk settlekan.
Okey, maksudnya ada juga team maintenance yang mana pelajar-pelajar diploma telecommunication ni boleh diambil bekerja lah, maksudnya begitu.
Boleh. Yang itu kena apply under operator lah, under client, maksudnya under oil and gas operator macam Petronas, Shell, macam saya Sapura ialah sebagai contractor. Kita buat platform saja.
Okey, buat platform saja. Maknanya yang itu direct dengan oil and gas ni.
Oil and gas operator. Betul.
Operator. Maksudnya skop kerja diorang kalau macam fiber optik tu lebih kepada maintenance lah, ataupun dia akan gunakan vendor. Kalau cik tahu?
Kalau untuk fiber optik biasanya tak semua operation team ni dia tahu pasal telekom. Normally memang dia akan panggil vendor jugalah. And then saya pun boleh encourage student pergi ke vendor untuk apply for the job.
Okey. Sebab kadang kita nak tahu juga dia orang ni perlu ada certification ke ataupun requirement daripada company oil and gas tu macam mana.
Tak ada. Dia bila kita kerja dengan, macam contoh kita kerja dengan vendor, so dia akan hantar ke training kan. So dia akan dapat macam certification, macam certifier yang ni boleh perform pricing, macam tu lah. So dia kiranya vendor, under vendor.
Okey, tak apa. Okey, terima kasih.
Okey, sama-sama.
Pelajar, saya buka lagi satu soalan. Jika ada yang ingin bertanyakan soalan, boleh bertanyakan di ruangan chat ataupun membuka button unmute anda.
Saya nak tambah juga untuk pergi ke platform, kita kena in good health, okay? Kena sihat, kena sebelum kita pergi ke ambil bosit training, macam training untuk ke offshore, kita kena buat medical check up kalau ada siapa yang ada sakit macam dia ada ada beberapa penyakit yang tidak dibenarkan untuk pergi ke platform. Sakit gigi pun tak boleh. Sebab nanti kalau sampai platform nanti sakit gigi susah dia orang nak hantar kita balik kan. So memang kena keep health lah untuk kalau nak kerja ke offshore. Keep a good health.
Terima kasih Puan atas makluman sebentar tadi. Jadinya kita telah sampai kepada sesi rehat waktu pertama. Kita akan berehat dalam masa 15 minit. Dan kita akan mula balik bermula pukul 11.15 pagi. Okey ke Puan Haniza?
Pukul 11, 15 ke 11?
11.15. 11.15.
Setengah jam lah ya. Okey. Okey.
Minta maaf Puan. Kita akan start balik pukul 11.
Okey, 11. Okey.
Terima kasih Puan.
Every day, around the world, energy powers progress. Looking back can help us look forward. On the far northeast coast of Malaysia, master top makers spend their life honing their skills to craft a gasing that spins for hours. The wise know that practice, timing, and teamwork will deliver success, measured here in precision, balance, and endurance. As it is in business, when technology and agility are driven by strategic vision, potential becomes reality. Sapura Energy's full spectrum of capabilities covers the entire value chain of oil and gas production, from exploration to development, production, rejuvenation, decommissioning, and abandonment. Each one of our divisions is a major player in their sector. Independently or working together, we deliver solutions from beginning to end. Today, we are a Malaysian company offering solutions and services to the oil and gas industry across the globe. Complementing our fabrication yard capability, our accomplished project teams have access to our fleet of state-of-the-art vessels. The flagships of our fleet, the Sapura 1200 and Sapura 3500, provide the best in offshore construction. These vessels have the versatility to operate in shallow and deep water and the ability to dynamically position, perform precise heavy lift and pipelay work. Sapura Energy's pipelay support vessels feature innovative control room and lay tower design. These vessels are now laying pipe in ultra-deep water 250 kilometers off the coast of Brazil at an incredible uptime rate of up to 99%. Sapura Energy's subsea capabilities run deep, from support vessels to diving and cutting-edge ROVs. Designed and built by Sapura Energy's subsidiary, TMT, in Perth, the Typhoon drops to the ocean bed. Nearly 2.5 kilometers down in the gloom, it locates the wellhead and goes to work under water pressures that would crush almost any other machine. Sapura Energy's drilling division owns and operates the world's largest fleet of tender rigs, with over 50% of the global market. market share. Our fleet of modern rigs extract oil and gas safely and efficiently in water depths up to 6,000 feet offshore and reservoirs up to 30,000 feet deep. Sapura E&P is a dynamic Asian-based independent active in exploration, development, and production. We have recently made significant gas discoveries offshore Malaysia, adding 9 trillion cubic feet to our existing reserves and resource portfolio. Our success has come from the core knowledge and expertise of our E&P team that continue to recognize good exploration acreage, execute exploration plans, and fundamentally develop and operate oil and gas fields in the most cost-effective manner. In every facet of the business, we aim for precision, balance, and endurance in a global marketplace. The best tools are only as good as the hands and minds that use them. So naturally, our most important investment is in people. Loyalty and longevity are the core values. We've positioned ourselves uniquely to integrate our services to clients by offering innovative technologies with multiple efficiencies and bespoke solutions to individual needs. Sapura Energy is built by entrepreneurs, engineers, and a diverse workforce, driven to deliver what we all take for granted, energy to live well and progress. Our journey continues to optimize energy for the world at large.
Untuk makluman, video yang telah dipertonton sebentar tadi merupakan video korporat mengenai Sapura Energy Berhad. Suka saya ingatkan sekali lagi, link untuk pendaftaran dan soalan pretest telah di-share di ruangan chat. Mohon semua peserta yang masih belum mendaftar dan menjawab untuk segera melengkapkan link tersebut. Kita akan mula kembali kepada slot 2, bermula tepat pada pukul 11 pagi.
Rehat je. Kemana? Alai.
Nama aku paling atas.
Let us continue with the second session of this webinar. I welcome Puan Haniza to continue her session.
Thank you to moderator. let me share my screen first. Okay, everyone can see my screen?
Yes, ma'am.
Yes, we can.
Okay. So for slide 2, we start with how the telecommunication industry enhancing oil and gas safety. Okay. So for this slide 2, there's a lot of video. So I request moderator can share the video later. Okay. Okay. So why it is important for safety oil and gas? So like in my as I mentioned in first session, the third element of the telecommunication in oil and gas is for safety and security. So we use telecommunication to enhance to improve the safety for oil and gas industry. So the first one, safety and security system provide communication during emergency situation. So during the emergency happen at the platform, maybe pagar will give the alarm of Papa. Papa means prepare to abandon the platform. So the operation team at the wellhead of CPP will deploy the life raft, and then we will bring over the life raft communication equipment and then abandon the platform. So later I will show about the life raft communication equipment. So after that, it's provide process and security control and monitoring of the facility. It is same also as I mentioned earlier that the unmanned platform will be controlled and monitoring from the CPP by using our backbone communication. So they will monitor such as the CCTV. They will use the CCTV to monitor the situation at the wellhead without going there. So they will be monitoring remotely. Next, it ensures safe operation and security of the installation. Okay. So what are the system involved? First, we have CCTV, public address and general alarm, pagar, radar beacon, we call recon in short term, life raft communication equipment, non-directional beacon. This one is for chopper landing. And lastly, we have explosion outdoor telephone system. Why we call the explosion outdoor? Because the telephone is the explosion proof, attack certified. Okay. So I share some of the example of the layout of the platform. This is the layout of the main deck, the first deck, the highest deck of the platform. So this deck is represent a wellhead deck. If it's TPP, it will be more bigger and more complicated. So I just show the wellhead one. So we go for the first one. Okay, you see this one, the CCTV, right? This one, Legend CCTV. So it located here. So this one is the project that I performed last year. Okay, this CCTV is we install the CCTV at the main deck so that the operation team at CCTV can monitor what happening here. Okay, because the CCTV is not the fixed one, it's the PTZ. It can pan, tilt, and zoom. So the operator at the CPP can zoom. If he want to see the flare boom, okay, the flare boom, yang macam corong api dekat platform tu kan. This one flare boom. So the CCTV they will zoom to this flare. to look, okay tak ada api tak keluar ke, okay. And then they will monitor here, PTZ, pan, around this one. Because the CCTV can pan about 360 degree. Dia macam full circle, can pan, okay. And then we have here, next we have NDB, non-directional beacon, okay. You see this is the heli deck pad. So we install the antenna at around the perimeter of safety net. This one we call is safety net. This one petak-petak ni we call safety net. So kita install antena ni adalah bare wire antena yang guna wire saja, bare wire. Dia tak ada, dia memang bare lah. Dia memang wire saja. Kita gunakan dia sebagai untuk antena lah. Antena kita pasang dekat perimeter safety net ni, and then it connected to the below this deck. Okay, you imagine this deck. There is a second deck below this deck. It is called mezzanine deck. So we install the NDB transmitter, their transmitter, their turning unit below the deck. Later I show the product, okay. And then it will connect to there. So this one is for heli deck, for the chopper landing. Okay, and then we have DMR antenna. Okay, this one, the green color. So this antenna is pointing to the true north of the platform. So it means that it pointing to the maybe at the side is a CPP side. So CPP side dekat atas sana. So antenna tu pointing ke sana lah. Okay, next we have Recon. Okay, this one is radar beacon. We install here for the Recon. Okay, this is just example how the location that we install our telecom system. Okay, we go to next. Okay, the first one, CCTV. CCTV used for monitoring the process and security control and monitoring of the facility. Okay, so CCTV we install at the main deck, mezzanine deck at the wellhead area. Wellhead tu tempat yang kita untuk drill minyak lah, untuk drill well minyak. And then we also install the CCTV near the boat landing. So boat landing ni biasanya dekat bawah sekali lah, deck yang the lowest deck. So kita install satu CCTV untuk kita tengok ada siapa datang, ada intruder ke, kan? For its purpose for security control and monitoring. So this one all controlled by the operation team at CPP through the DMR or fiber or wireless broadband lah. So secondly is a pan, tilt and zoom. Okay, pan macam ni lah. Dia gerak seng. It can turn over 360. For this product, can turn to 360 degree. Tilt, it can tilt ke atas 180 degree, and then zoom. Zoom about 30 times zoom. It depends on the product. Sometimes it's different. Sometimes it's a 30 times zoom. And it also can work on night because there is a light here. But we cannot see the light. It's just a LED light. So during night, it will shift to mode, night mode, which is black and white mode. Okay. So this type is the hazardous area. For example, this one is the hazardous area. It also come with indoor type. Sorry about this one. We also got the fixed type. We need to say fixed is a fixed. It's pointing on the one direction only. Maybe the project, the camera requirement want to point to the flare only, on the boat landing only. So it cannot turn. It cannot turn to 360 or pan to 180. Is a fixed type. Okay. For this example, this one is the PTZ type. It can turn tilt, zoom. Okay. So normally fixed type we use also in indoor type, meaning to say in the aircon room, in the safe area room, safe area. So this one is the hazardous area. This CCTV can sustain the high temperature about 60 to 70 degree, very high temperature, very hot condition. So it can sustain. So this CCTV also is very, because it's the electronic part, so it's very sensitive. Not all personnel can open this one. Is can open at the side or open without consent from the factory or manufacturer of principal. If broken, we need to send the product back to the factory, or we need to call the factory guy, the principal, to come over to have a look what happened to this CCTV. So it's a very sensitive system lah, product. So this one okay. Next, CCTV cabinet normally at CPP platform. So normally for CPP and wellhead, we extend the system. We will not have a new system at the wellhead, but we will extend the system from the CPP, meaning to say the central processing management CCTV is located inside CCTV cabinet, so it located at the CPP, but we extend maybe one let's say we need four CCTV at the platform, so we extend 4 license to the CPP, to the wellhead from CPP, and then it will, so that's why the monitoring at the CPP, because the management cabinet is at CPP. So we only extend the CCTV only at the CPP. Okay. Workstation also at CPP. That's like I mentioned earlier. They want to monitor flare or intruder or operation team coming to the wellhead, etc. And then for the cable, normally for CCTV, we use composite cable, which consists of power plus internet cable inside the composite cable. Because normally power will come from the main panel, and then Cat6 is to send the data from this CCTV to the main panel on the wellhead. If less than 90 meter distance between CCTV and panel, we can use Cat6 cable. But if more than 90 meter, we need to use fiber optic cable, because 90 meter over using Cat6, it will be a loss, and we will lose the connection of the CCTV. And then nowadays, all CCTV we use IP-based, meaning to say Ethernet connection. There will be not analog, and we do not require encoder, decoder, and so on for offshore. Okay, so this is example. This one is the CCTV camera. This is the JB junction board. Okay, junction board. This one connected the power, the Cat6. Okay, you see the cable here. 8 pair will be represent the Cat6. This one. Okay, this one represent power. Okay, and then this one we have a washer tank. Washer tank is required. It depend on the project. So during the weather condition, operation cannot see, they will push the button to wash up the lines. So dia akan ni lah, wash lah, macam wiper kat kereta kan. Okay, they hit the button and then they will wash here. So this one example of the installation, it installed on the support. This is the unit, camera unit. Oh, sorry. This one is the JB. And then there is a cable going to the main panel of the system. Okay. That's all for CCTV. We can have a look for the product video. Can moderator help me? to project the video?
All right, sure.
World leaders in security and telecoms systems presents the new Zcam 4 range from Zcam. A truly revolutionary design, our cameras offer a previously unattainable level of positional accuracy, repeatability, zero backlash, smooth motion and silent operation. Introducing cutting-edge innovation to the CCTV industry, the Zcam 4 utilizes our specialized high-speed, high-torque direct drive brushless servos for best-in-class performance. Intelligent illumination made possible with adaptive IR provides excellent visibility in low light conditions synchronized to optical zoom distance. Incorporating the industry standard ONVIF communication interface, together with integral telemetry command protocols, allows for seamless integration with leading IP video management systems. For connectivity, provisions are made for both optical fiber and Ethernet access. Weighing only 22 kilograms, the explosion-proof Zcam 4 incorporates its own power supply, window wiper, high-definition optics and illumination. This way, there are no additional requirements for external enclosures. With an IP68 weatherproof ATEX IECEX enclosure, constructed entirely from AISI 316L stainless steel, our PTZ IP cameras can withstand the most demanding situations in hazardous and corrosive environments. For global distribution, certified operating temperatures range from -60 to +70 degrees Celsius. Continuous 360-degree rotation is available in the touring mode as well as super-fast return to programmable preset positions. This provides the most accurate and sophisticated positioning for stable, long-distance tracking. Designed for longevity and zero maintenance, having no gears or belts to wear out, the Zcam 4 offers you military performance at commercial cost. The Zcam 4, for best-in-class innovation and performance.
Okay, can I share my screen?
Okay, sure.
Okay. Okay, that's the example of the Zista product video. I'm not selling the product, but this is just example to expose students to the product, the offshore product. So the CCTV, the explosion-proof CCTV, like the picture, is only used at the very hazardous area. In normal condition, onshore, I think there is no requirement of this type of CCTV. Only required at offshore. So it will, if anything happen inside the CCTV camera, the JB, okay, maybe there's spark here, it will keep the fire inside here. That's why we need the explosion-proof. Explosion-proof means explosion-proof. It will not if affect nearest system for the CCTV, and then we will prevent the explosion of the platform or at the certain area. Okay, that's the hazardous area or ATEX certified equipment used for functioning for. Okay, let's move on to explosion telephone system. Okay, for communication, it used for communication between wellhead platform and CPP or to onshore client office during operation. So, during operation team went to wellhead platform, maybe they want to call because they cannot bring their cellular phone, and then cellular phone also no signal there. So this is the type of method of communication. if they want to inform, want to request or inform personnel at CPP or onshore to report, so they will use telephone. So this is the main thing lah, the main function of telephone system at offshore. So the IPBX, the telephone exchange is normally at client office or at CPP. Like I said, at the wellhead, this is unmanned platform, so all the main system located at CPP or client office. So everything will extend back to CPP, to wellhead, between wellhead and CPP, extend to wellhead. Okay. We require hazardous area type depending on the location, meaning to say, safety, the platform was assigned by zone 2 or zone 1 or zone safe, so it's depending on the location. Normally at offshore we use all exploration proof, so yeah, they got EX certified, attack certified product. This one is the telephone. Okay, so it required analog telephone adapter before going to IPBX. Okay, because the telephone is using the telephone signal, right? Not the internet signal. So in order to connect to the IP-PABX, which means the PABX exchange using the internet base. So we need to have the analog telephone adapter before going to the IP-PABX. So this adapter will convert the telephone signal, pair signal, to the Ethernet signal, and then connect to the IP-PABX at CPP, for example. So that's so after that, there will be the telephone system will be successful, and we can call in and then call out. CPP also can call wellhead. Okay. It is required for offshore platform. It is required acoustic hood. This one we call acoustic hood. It will lower down the noise level, and sounder. This one is sounder, and beacon due to loud noise of the platform. Okay, the platform ni dia memang bising dan dekat laut memang bising dan memang banyak noise lah. So memang kalau nak call kita akan gunakan hood ni lah. Operation team akan pergi ke hood ni. Dalam hood ni ada telefon lah. Macam telefon kan. So jadi kita akan, dia ada certain level of dB lah untuk acoustic hood dekat dekat wellhead ni. Dia untuk prevent lebih kurang 30 dB noise, so dia akan more clear lah. So bila kita call tu akan lebih clear. So untuk yang ni nampak tak, dia tak ada acoustic hood kan. So yang ni area ni dia less noise. So memang kita dah certain area memang kita ada level of noise dia lah. So untuk yang dekat area ni kita panggil temporary shelter lah. Macam operation team before going back to the CPP, macam tunggu boat ke, dia akan duduk kat sini lah, temporary shelter. Dia kiranya yang ni macam kita panggil temporary shelter lah. So the noise level sini dia lebih rendah. So dia tak not required the acoustic hood. So bila ada CPP call coming from the CPP to wellhead, so they will initiate the telephone, and then in same time they will initiate the sounder and beacon. So bila ringing, and then the sounder we give sound of someone calling, and then the light flashing beacon, because the noise level is very high. So orang tak tahu ada orang telefon ke, ada orang telefon ke macam mana. So dia akan nampak lah, operation team akan nampak dan akan dengar bunyi alarm, and then this one flashing ni kan, flashing beacon ni akan dia flash lampu lah. Yang ni lampu kuning, dia akan flash lampu, and then operation team akan nampak. Lepas tu dia akan pergi ke telefon untuk angkat call daripada CPP onshore, ada apa-apa information untuk orang yang pergi ke wellhead. Okay, boleh faham tak? Saya explain dalam Malay and English lah ya. Okay, okay. Clear? So this one this is JB of the telephone. So this one is a example of installation support. They install on the pole. This one we call D50 pole. Okay, for your information, all all steel material at platform, they have their own material. Not all steel can be used at offshore because due to corrugated, okay, due to karat, corrugation, so there is where they need use the required steel. Okay, ada jenis-jenis steel lah yang boleh digunakan. So yang ni kita untuk JB ni kita pakai stainless steel 316 SS, the highest spec of JB in the market. So yang ni dia akan tahan sustain of the corrugation, corrugated, semualah. Air pun tak boleh masuk due to they got the IP level, ingress protection, not IP base lah. IP protection, for example, IP60, IP50. Nowadays, our handphone, like, okay, they can sustain sustain in the water for a while, for a minute, due to the product itself certified by IP50 or 66. It means that it can submerge on the ataupun terkena air ataupun terendam dalam air untuk beberapa minit lah. Dia ada kiraan dia lah. Depends on the requirement. So yang ni normally we use IP66 is a requirement for this company. So this JB installed and the support below the telephone, and this one cable coming from the main panel is contain the pair cable. Okay, pair cable. Pair cable, normally we use 2 pair or 1 pair cable for the telephone. And then the other cable going to the hood, acoustic hood. And the acoustic hood, and then going to the telephone itself. And then one cable will be back to the main panel that located at normally at the center of the platform by the master area, and it contain the adapter. Okay. Central equipment tu dia dalam explosion proof because most of the telecom equipment, switch, adapter, this one is not available for outdoor unit of the product. It's only safe area, so we need to install inside the enclosure. So that's why we call the main enclosure for telecom. Okay, I hope you understand. Okay. Tadi dah kan? Okay, we going next. Okay, we going next to the radar beacon, or we call it recon. Tadi video tu saya rasa dah project kan yang tu. Okay.
This video from Zistel is an introduction to our ETO1T rugged telephone series. Zistel design and manufacture a range of telecommunication products developed to deliver reliable service in demanding environments and mission-critical situations. The ET01T is a rugged yet lightweight analog 2-wire telephone device, available in both weatherproof and explosion-proof models. A high-visibility orange polymer enclosure carries a stainless steel tactile keypad large enough to be operated by gloved hand. An integral waveguide sounder emits audible signaling tones. For high-noise ambient environments, explosion-proof and waterproof extension signaling combined devices can be linked to the unit. The ruggedized handset features an armored stainless steel cord, and the solid-state single-bodied cradle secures the handset even under severe mechanical shock. The unit can support both handset and noise-cancelling ear defender headset operation. The Zistel ET01T delivers a cost-effective solution to establishing reliable two-way communications on an industrial facility.
With
Okay. That's all about telephone
Okay.
system. Let me share my screen. Okay, we move on to radar beacon, or we call it recon. Okay, this is a marine radar beacon. Is a navigational radar aid beacon that used to indicating the position of the offshore facility. So in this case, to indicate the position of the wellhead platform or CPP platform. So if, one platform shall have one record. So the beacon function will assist the other party ship's radar in locating and identifying a particular offshore structure. So during the vessel pass through or near to the platform, they will see this recon signal in their ship radar. So it will avoid the corrosion, so they will notice that there is platform over there. Okay, so the beacon automatically transmit a coded signal when it receives a signal from a radar of a seagoing vessel. The range, bearing, and identification information of the offshore structure will then appear on the display of the ship radar. Okay, like I said just now. Oh, sorry. The purpose of the recon is to alert and provides warning to near vessel of potential hazard by providing location or position of structure in all weather or restricted visibility condition. The beacon uses Morse code as the response code when it is transmitted. So the recon will transmit a Morse code every time. So the ship radar will recognize the platform. So how they know the platform name? So every recon there is we assign one alphabetical number as we call it as a call sign of the platform. So on the radar, ship radar, it will show maybe A, B, or C, and so represent the info of the recon. Okay. So this is the example of installation at offshore. Okay, ignore this circle. So this recon is attached with their JB. Okay, this is the explosion proof. Okay, explosion proof type recon. In the market, I think there's only two only two product is comply with the ATEX certification. So this one is one of the product. It attached with the JB. So this one is cable coming from the field, electrical cable to power up the recon, and then this cable going to the switch. This one switch is used for switch off or switch on. This one we use during the maintenance. Okay, as you know, the power is coming from the electrical panel. So during maintenance, the operation team no need to go to the electrical panel, just switch off here and then continue to do the maintenance of the recon. Okay. Basically, for this installation is required clearance and cannot near to the steel. Okay, you see, it's like an upper and installed at the main deck and require a clearance. If it's near the steel, it will interfere the signal, and then the radar cannot see the platform. Okay. This is only for basic information of the recon. Okay, I think we can continue to the video. So the video, it consists of recon and the lighting navigation lighting. But I want to show only the recon product itself. Saya nak menjawab soalan daripada Muhammad Irfan. Okay. Saya ingin bertanya tentang pekerjaan offshore. Jika rangkaian telekomunikasi terputus, apakah tindakan drastik yang akan diambil oleh pengurusan offshore? Okay, soalan yang bagus. Untuk main communication backbone, dia semua main communication backbone ialah sistem yang redundant. Okay, dia ada backup system. Dia jarang-jarang sekali dia akan shutdown, dia akan terputus, shutdown, kecuali platform meletup ke macam tu lah, tu yang paling the worst case. So, dia akan jarang-jarang sekali terputus hubungan sebab sistem yang kita design semua redundant. So ada backup. Main link akan jalan. So bila main link terputus, backup link akan terus straight away akan take the signal. Macam DMR macam tu, wireless broadband pun macam tu, fiber optic pun macam tu. Semua redundant. Macam fiber optic tadi kalau perasan, dia ada dua link. Dua kabel. Satu, the first link, the second link, dia akan satu putus and then the satu lagi akan take over. Yang tu dia switching tu dia akan berlaku pada switch, Cisco switch. Kita akan configure switch tu akan untuk switching bila one link down. So another link akan take over. Tapi ada yang masalah yang saya pernah counter masa projek dalam 4 tahun lepas lah. Sebabkan DMR link ni, the IDU unit dia ni very hot, okay? Dan kita install dia dalam enclosure. Selepas itu switch yang dia connected to the switch, but the switch is a normal type switch that normally we install inside the aircon room, but we install in the enclosure. So during the operation, the temperature rise. Okay, temperature rose below the IDU can sustain. Okay, macam contohlah kita bagi enclosure ni JB ni, dalam ni ada IDU unit, ada switch. Okay, enclosure ni kita kena buat calculation, heat dissipation calculation. Kita akan hantar apa-apa maklumat produk yang kita akan install dalam JB tu kepada factory explosion proof enclosure untuk dia calculate temperature bila operation, during operation, how much the temperature will happen inside the JB. So bila temperature tu, salah satu produk ni temperature dia very high, then dia affect temperature of the IDU. IDU tu dia tak boleh sustain sampai 70, maybe dia normally dia sustain sampai 50. So dia terus panas, dia akan auto shutdown. Bukan satu link je, dua-dua link dia shutdown. Okay? So in order to answer your question, operation team daripada CPP dia akan pergi ke wellhead yang shutdown tu dekat wellhead lah. So dia dapat detect ada shutdown dekat enclosure Telecom ni. Dia akan naik boat pergi ke wellhead and then dia will power up the link, and then dia bukan macam selamanya terputus tau. Dia tiba-tiba dia shutdown, lepas tu kalau kita on balik dia okay. And then after certain time dia akan shutdown balik. So and then they will engage vendor. Okay, vendor, and then we come up, we report macam mana, report lah apa yang terjadi semua. So vendor kita akan pergilah, sebab dia ni adalah salah satu vendor juga, design daripada vendor juga, and then vendor akan rectify lah benda tu as soon as possible. So dia untuk yang projek yang tu, saya dan vendor kita come up with another solution. We replace the switch that can sustain the high temperature. Maksudnya and then it also sebab switch tu yang Since tu dia indoor type, so kita tukar pada hazardous type ni. Walaupun dia pasang dalam enclosure, kita tukar kepada hazardous type. So dia akan lebih bertahan lah dia punya temperature tu. So to answer the question, so the operation team we engage the vendor and then vendor will rectify the problem lah. Okay ke Ifan? Saya menjawab soalan tak? Mana Ifan tadi? Sekejap hazardous area apa? Okay, soalan kedua. Saya nak jawab sekarang ke atau jawab sekejap lagi ya? Ataupun saya habiskan yang slot 2 ni dulu? Moderator?
Kalau Puan rasa Puan nak jawab sekarang pun boleh juga.
Okay, untuk soalan daripada permainan okay, boleh tak Puan elaborate on the hazardous area di platform oil and gas? Okay, kalau tadi saya ada explain safety untuk platform ni, dia ada hazardous area punya drawing. Okay, yang ini safety team, safety department akan keluarkan drawing ni, dan dia akan identify platform dekat mandek ni zone berapa, dekat for the top deck is mandek, and then the second mezzanine, cellar deck, and then boat landing deck. So dia akan assign normally for platform all area they will assign zone 2. Zone 2 which mean dia kena meet 40 to 60 degree temperature. So semua equipment yang kita nak install dekat atas platform tu kena meet requirement for the up to 60 degree temperature. 60 degree tu tinggi dia memang panas. So memang kita kena cari produk yang boleh sustain that temperature. So kalau macam zone 1, zone 2 ialah dia paling yang zone dia start daripada zone 0, zone 1 and zone 2. Zone 0 paling bahaya sekali. Saya tak pernah lagi tak pernah lagi install barang dekat zone 0. And then my past project pun dia sampai zone 2 je lah. Zone 2 pun dah kira very about hazardous area lah. Semua produk kena ATEX certified. Okay, zone 1 pun tinggi juga. Zone 2 up to 60 degree Celsius. So semua produk yang kita beli tu kita kena meet the temperature requirement. Kebiasaannya dia ada drawing, kita tengoklah drawing tu. Drawing tu kalau zone 2, so kita akan beli semua barang zone 2. Zone 2 tu beli untuk temperature yang very high temperature produk. Macam yang tadi CCTV kan, macam hazardous, macam wireless broadband punya audio. Kalau macam barang tu tak ada, not available in the market, kita beli yang normal type tapi kita install dalam enclosure EXD, exposure proof tadi. Dia bukan apa, dia sebabnya dia zoning ni sebab dia kalau ada satu spark pun dia boleh initiate fire, sebab dekat platform tu dia ada discharge gas. Dia memang kalau ada spark sikit pun boleh create fire kan, boleh create flame. So kita kena install dalam explosion proof punya produk lah, explosion punya JB ataupun enclosure. Okay. Okay, saya menjawab tak soalan tadi? Saya harap saya menjawab lah ya. Okay. We move on to next. Okay. Next is public address and general alarm, pagar. Okay. with the public address general alarm PAGA system is the solution for harsh industrial infrastructure and facility under the most challenging environmental condition. Okay, this means that hazardous area, okay? Senang je. Dia ni, yang ni dia cakap most challenging environmental condition ni hazardous area, hazard, harsh industry, very high temperature condition, memang paling bahaya lah, tempat yang paling bahaya kiranya. So it's a critical equipment needed to deliver clear message and alarm throughout the facility to guarantee the safety of personnel. Personnel ni operation team tadi tu lah, ataupun orang-orang yang bekerja di atas platform. Okay, this one used for generate alarm and broadcast announcement. Okay, so PAGA ni akan generate alarm dan broadcast announcement. Macam dia akan broadcast ada apa bahaya ke, okay, and then kalau alarm dia akan create, dia akan automatic generate alarm sebab dia ada input daripada fire and gas system, daripada instrument. Dia ada banyaklah multiple input daripada other system as well. So it can automatically generate alarm. There is a type of alarm, several type of alarm, and then they will broadcast. Tapi untuk personnel offshore, dia mesti faham alarm tu apa. Sebab dia orang memang pergi training untuk tahu alarm tu apa. So bila PAGA ni generate alarm untuk macam the worst case papa, prepare to abandon the platform, okay, meninggalkan platform tu. So bila alarm tu keluar, dia akan notice the personnel untuk cepat-cepat tinggalkan platform tu dengan menaiki life raft ataupun survival craft. And then broadcast announcement. Okay, kalau ada orang nak broadcast announcement, nak announce apa-apa, so boleh guna PAGA ni lah. Sebab dia ada dekat certain area ada access panel. Access panel kita boleh pergi kat situ, kita boleh tekan and then announce apa yang nak di-announce lah. Okay, and then for PAGA required sound coverage study to ensure the speaker location we cover to all area. Okay, yang ni sound coverage study ni biasanya kita minta vendor akan perform lah coverage study untuk sound coverage, so that mean all area will be covered by the sound of speaker. Nanti kan kalau kita pasang kat sini, kat sebelah sini tak dengar. So kita kena pasang dekat tempat yang lebih baik lah, yang lebih better, untuk noise cancellation. Sebab semua tempat platform memang bising. Okay. And then is also in redundant system to avoid any failure. Okay, that's why this one I said about the being backbone. Also is applies on PAGA, is required redundant to avoid any failure. So we got PAGA A and PAGA B. Okay, maybe you notice that PAGA A and PAGA B, it will be a different cabling layout, maksudnya kita lay the cable different routing. Okay, macam PAGA A, PAGA B, dia different location. PAGA A maybe kabel dia lalu belah sana, and then PAGA B lalu belah sini. Dia takkan sebelah-sebelah. Sebab if anything happen at that side, nanti dua-dua akan down. So tak boleh lah. Redundant ni, sistem dia memang dia akan lay the cable in different path, different routing. That's why we call it redundant system to avoid any failure. Okay. Okay, for the PAGA component, we got the main cabinet. This one is PAGA A, this one is PAGA B. Okay, dalam ni inside the cabinet we have the management panel, the amplifier, the telephone. So this one is the input that we can give signal to the PAGA to initiate the alarm. Okay, we can connect to the PABX to fire and gas safety. If fire happen at the platform, so the PAGA we automatically announce. Okay, this one all we can use the network configure on the management panel. One PAGA A, PAGA B. This is the speaker. This one is the beacon. Come with speaker and beacon. Dua-dua ada untuk sound dan beacon lah, untuk flashing light Sebab bising kan orang pun tak dengar, kadang-kadang orang pun tak dengar beacon ni atau orang nampak batu with eyes, lampu. Okay, this one speaker juga. Okay, yang ni ialah access panel. Access panel ni macam we want to announce something. Okay, personnel want to make announcement, so dia akan pergi kat panel access panel ni lah. Kenapa dia ada lain? Sebab dia ada beberapa location yang dia akan letak lah, ikut depends on the area tu, macam mana keadaan dia, zoning dia. Kalau macam ni letak dalam safe area, okay, safe access panel, safe, okay, ni dalam bilik lah. So override ni, ni dekat dalam bilik juga. Yang ni IS access panel ni, yang ni dekat luar. Yang ni dia boleh sustain apa-apa apa nama, temperature, high temperature. Okay, yang ni ialah dia punya speaker untuk pagar B pula. Okay, ni beacon pagar B. Okay, dia akan different Dia semua path ni, kita lay kabel ni different way. Different routing, tak boleh routing sebelah-sebelah. Nanti kalau terbakar kat situ, habis semua. Ni habis, ni pun habis. Okay, so we give power supply. Power supply, and then secondary power supply. Power supply pun kita bagi redundant. One down, one will be up. So this one under electrical lah. Electrical memang filosofi dia semua redundant. Power memang ada dua input power. Dia tak boleh satu je. Kalau satu, one down and then another one tak boleh jalan kan. So dia akan bagi dua power yang berlainan lah. Redundant power supply. We call it redundant power supply. Lagi sangat ke? Okay kan. So this one, sound coverage study. Okay. Sound coverage study ni yang vendor buat lah. Vendor buat. Okay, ni dekat mana dia macam ni sound dia sampai tak kat semua area. Okay, yang ni dia buat semua okey lah, kiranya semua akan dengar lah kalau ada sounder and then the beacon nampak and then the flashing beacon nampak semua lah. So dia ni contoh macam mana kita nak pasang. Okay, speaker tak boleh ada dekat dekat dengan macam voice besar of the noise source. Dia mesti letak dekat noise source tu. Macam tempat tu bising kan, kita letak speaker dekat tempat bising tu supaya dia akan cancelling the noise. So orang personal ni akan dengar sound dia tu. Okay. That's the example of the pagar component and sound coverage study lah. Okay. Let moderator to head the project the video.
This video from Zistel is an introduction to our PAGA system. Initially designed for oil and gas installations, it is now also used in the nuclear, marine and the defense industries. For any PAGA system to work, you need the following 4 components: microphone input, amplification, management, and output field devices such as loudspeakers or beacons. For microphone input, Zistel have a range of products, including IP66 safe and hazardous area units with duplicated microphones, membrane keys, as well as devices incorporating touchscreen access panels. With our amplifiers, Zistel has 2 main options. First, our cassette-based, hot-swappable Class G amplifiers. Very compact in design, we can accommodate 9 amplifiers in a subrack and up to 5 subracks in a 19-inch rack. This is a total of 45 amplifiers and over 15 kilowatts of amplification in a single rack. The second amplification option is our compact pause amplifier, a minified PAGA system in a 3U chassis. The device incorporates a primary path for speech and alarm tones, utilizing modern features such as touchscreen access, Ethernet, fiber optic connectivity and hot standby. Up to 2000 watts can be provided from a single unit. The core operation of the PAGA system is not reliant on software. Software is not in the critical path of the design. Consequently, our systems have very high reliability. Built on top of this core system, our ZMUS management software layer provides operators with an intuitive interface and flexible control through 4 simple color-coded panels. These include routine, emergency, intercom and events. The latter being a historical data logging screen which shows previous activations with time date stamps. The ZMUS PAGA management system is scalable from simple centralized systems to large distributed networks covering hundreds of nodes. For the supply of field equipment, Zistel manufacture our own range of beacons, including xenon, high-intensity LED, single and combined multicolor units. For audio, we work with the leading manufacturers of speakers. We have developed the leading technology for individually addressable speakers, ZADs. This is interfaced with our ZMAS management software, enabling system speakers to be individually monitored and volume tappings changed by touchscreen at the central locations. Simple, flexible, reliable and using standard single-pair cable. This completes our introduction to the ZizTel PAGA system.
Okay, let's continue. Next, next system is the next system is the non-directional beacon. It is used for the helicopter landing. Okay. Non-directional beacon is the radio transmitter that assists helicopter pilot in navigating landing on and identify platform facility by transmitting call sign, which is used Morse code, same as recon, call sign of the platform, and thus provide direction for the helicopter to facilitate to the facility, such as from CPP. Normally, if chopper wants to go to the wellhead, the chopper normally is from CPP. So they will turn on the NDB. This one is can remote control from the CPP. Is controlled to on and off only. Okay, before they going to the wellhead, so the operator will switch on the NDB at wellhead remotely, and then after that, chopper will find the Morse code of the call sign of the NDB. Okay, call sign is we configure call sign individually for the platform name. Normally, if the platform name ABC, so we use maybe we can the platform name is longer, so we can shorter with the initial name. Maybe can be CGA. Okay, so they will we can configure the call sign at the NDB, and then after that, Helidat will know the cosine of this NDB and will navigate to landing to the wellhead. Okay, so this is the installation of the transmitter. This is the transmitter unit of NDB. This one is the auto turning unit. Okay, this cable, this point is connected to the bare cable. If you remember my slide, okay, this one is the bare cable of the NDB. Okay, the bare cable is represent the antenna. So the bare cable we connect to the ATU, auto turning unit. Okay, auto turning unit, this one is used to it's like calibrate the antenna, because during the chopper landing it will affect the level of the sensitivity of the antenna, so it will do their job by turning to the correct position or correct frequency of the antenna. So it connect to the transmitter. Transmitter is to on and off and give the signal to the ATU, and then it will transmit the cosine through the antenna so that helicopter can know the cosine of the antenna. Okay. Okay. Please help moderator.
A non-directional beacon is an AM radio station used for aircraft navigation. The automatic direction finder, ADF, inside the airplane receives the NDB signal. The ADF needle simply points toward the selected NDB station, providing the pilot with a bearing to the station. Commercial AM radio stations may also be tuned and received with the ADF. As with the VOR, select the appropriate frequency and configure the airplane's audio system so that the NDB's Morse code identifier is audible. Each NDB has a unique 2- or 3-letter identifier. Since the ADF has no flag to indicate reception of the NDB, the pilot must continuously monitor the Morse code identifier whenever the NDB station is being used. The ADF needle points directly towards the NDB, displaying the bearing relative to the nose of the airplane. This relative bearing is simply the angular difference between the nose of the airplane and the station's location. Turning the airplane until the needle is pointing directly ahead results in the airplane being pointed directly at the station. The magnetic bearing is much of the time a more usable number since it tells you what the magnetic direction to the station is from the airplane. To find the magnetic bearing, add the airplane's heading to the relative bearing displayed on the ADF needle. For example, if the ADF needle showed a relative bearing of 150 degrees and the airplane was on a 030 heading, then the magnetic bearing to the station is 180 degrees. This means a 180 degree heading would point the airplane at the NDB, so the NDB is south of the airplane. Adding or subtracting 180 degrees from the magnetic bearing to the NDB gives the magnetic bearing from the station. In our example, 180 plus 180 gives us 360 degrees from the station. This means the airplane is north of the station. Most pilots memorize a formula to aid them in learning to use NDBs. MH plus RB equals MB, or magnetic heading plus relative bearing equals magnetic bearing. To fly directly toward an NDB, first turn the airplane so the needle is pointing straight ahead. The airplane is now pointing directly at the NDB. Just like with VOR navigation, the airplane will soon drift off course without proper crosswind correction. The process is the same, the pilot only needs to understand the different display of information. Maintain your heading and observe the movement of the needle. If the needle moves right or left, you will have to turn your airplane right or left to stop the airplane from drifting off course with the wind. For example, let's say the needle moves 5 degrees to the right. We must turn right to correct for this, so we turn 15 degrees to the right. Since the ADF needle always points directly at the station, it is now pointing 10 degrees to the left. The tricky part is to realize that we want the needle to show an angle equal to our wind correction. Since we turned 15 degrees to the right, the needle should show 15 degrees to the left of our nose. At the moment, it shows 10 degrees left. Maintain this setting and watch the needle for a few moments. Let's say the needle continues to move to the right, and now it shows 5 degrees left of course. This is an indication that we're still drifting. A greater course correction is required. We turn another 15 degrees to the right, so now our total wind correction is 30 degrees to the right. So we want the ADF needle to show 30 degrees to the left. It shows 20 degrees left at the moment. Maintain this heading and wait. After a few moments, the needle begins to move to the left. When it shows 30 degrees to the left, we're back on our original bearing to the station. At this point, we know that 30 degrees is too much wind correction and 15 is too little. We elect to turn 10 degrees back to the left, which will leave us a 20 degree right wind correction. The ADF needle points 20 degrees left of course, and that's right where we want it. Maintain this heading and wait. Continue bracketing until you find a heading where the ADF needle does not move left or right, and make corrections as necessary.
Okay, that's all about NDB. It's basically the NDB is to functioning is to navigate the chopper for landing and the direction to the platform. Okay. We move on to the last system, which is life-raft communication system. Okay, life-raft is the raft. Survivor is like a survivor craft. Life-raft is like a boat to to left the platform, to abandon the platform during emergency. So this equipment, okay, this life raft communication equipment is to be used for communication during emergency situation such as abandoned platform or any condition where there is a need to deploy and use the life raft. Okay, this one will be used only to during abandoned platform. Cannot use on the platform itself. Okay, at the sea. After we deploy the life raft and the personnel on the life raft, and then far away from the platform a bit, and then they will need to initiate three device for emergency what we call that, rescue, okay. So it consists of EPIRBs, emergency positioning indicating radio beacon. So this one EPIRB, AIS SAT, so this one the SAT, okay, and VHF FM GMDSS AirTags portable radio, okay, AirTags certified by AirTags. This one is the radio, okay. So for this three type of equipment is a different type of rescue solution, okay. This one ASAT is will use a different frequency, this one different frequency, and also this one will be using a channel 16. Channel 16 is the marine channel for emergency rescue. So this one, all three equipment is the compulsory, okay. To comply the SOLAS requirement. SOLAS is the safety life at sea. We need to have these three equipment on the platform, on the vessel, okay. So during the abandon, the personnel will take these three items inside the box. This box is we call it an emergency communication cabinet located next to the life raft to storing the all equipment, and will be brought to the life raft during emergency. So before they took the life raft, they will need to bring the three items. Bring over the three items into the life raft and then deploy and then left the platform. This one only used during the abandoned platform. Okay. I think that's all for life raft. Okay. Let's watch some video.
So you've entered your survival craft, but now you need to be rescued. Even with ships searching in the correct area, narrowing down your exact location can be a real challenge. That's where a SAT can help. They attract the attention of passing vessels by actually drawing on their radar screen. Activated correctly, it will point the searchers in the right direction, increasing your chances of being rescued. SART stands for Search and Rescue Transponder. It's an active device, meaning it transmits a signal to draw attention to itself. It's triggered when it detects a pulse from a radar. As soon as it does, it transmits multiple pulses straight back, painting a series of 12 distinctive echoes on the screen, guiding the searching vessel towards its location. They operate at 9 GHz, which means they show up on an X-band 3 cm radar screen. Day to day, the units themselves require very little maintenance. All you need to do is make sure they're clean and dry, check the battery expiry date, and test them monthly. Every unit is different, so you do need to check the instructions. On this unit, you can just slide the switch to the test position to temporarily activate it. It will indicate whether the internal test is successful, often with a light. If you have radar, you can also check the screen to check it's responding correctly. In an actual emergency, you need to make sure you take it with you. There's no rush to activate it, especially if you're still close to your original vessel. That will paint a large echo anyway, and may even block the SART's transmission. Once you are clear, you can then set it up. To activate the SART, you normally just need to remove a pin. It should then indicate to you that it's working. Once active, it needs to be mounted as high as possible. The higher it is, the further away it will be detected. In the water, you can expect only a mile or so. On the floor of a life raft's not much better, maybe 2 or 3 miles if you're lucky, but mounting 1 metre high, it must be able to be detected at least 5 miles away. 1 metre is the height of IMO performance standards, and it should have been designed to comply with that. SARTs have enough battery to last 96 hours in standby mode, that's 4 days, and 8 hours in transmission mode. Of course, it should only actually be in transmission mode when another vessel is close enough to detect it. If you have multiple SARTs, it's important to only activate one at a time. Using one ensures that the radar return maintains its distinctive nature and can't be confused with another echo. The other point to note is to never use a SART and a radar reflector close together. There's always a chance that the radar reflector will block the SART's signal. Once it's all set up, you just need to wait for a radar to be close enough to activate the SART. For the approaching vessel, the first sign that there's a SART operating is the characteristic dots on their radar screen. At long range, these show as 12 dots in a line, originating from the SART's location. The first return is the SART itself, and the further dots are the extra echoes generated by the SART. The extra echoes will be 0.6 miles apart, so they can be seen best on a 6 or a 12 mile range setting, as they will span a total of 7.2 miles across the screen. The precise range that the SART is first detected does vary. We've already spoken about the importance of mounting height. Another major factor is the height of the radar looking for it. For a surface craft with a scanner height of 15 meters, you can expect those performance standards of 5 miles for a correctly mounted SART. This then increases for bigger ships with higher radar scanners. The greatest range will be from aircraft searching around 3,000 feet. They may pick it up at even 40 miles away. Once the SART begins generating these extra echoes, it indicates to its user that it's under interrogation. Often this is by a flashing light or an audible signal. It tells the survivors there's an X-band radar operating nearby, and should act as somewhat of a morale boost. Knowing that there are vessels close by is also a good indication that traditional flares will be spotted. Even at maximum range, rocket parachute flares should still be visible to the vessel that has activated the SART. Hopefully, now the SART, or maybe even the flares, have attracted the attention of the other vessel. They can use the shape of the echo to locate the survival craft. As they draw nearer, the dots on their radar screen become arcs. This is because the scanner is picking up the returns across a larger angle. The closer it gets, the larger the angle that the scanner can detect the SART, so the larger the arcs become on the screen. Eventually the arcs become full circles, showing that the approaching vessel is now very close to the SART's location. If all goes well, the survival craft should be clearly visible, and survivors can be rescued. They're not cheap, but if you're bobbing in a life raft and need rescuing, you'll wish you had one.
Madam,
Can you hear me?
Scenario. You're in the middle of the ocean, and your ship sinks so fast you can't even send a distress. It might not seem real, but it can happen. The MV Derbyshire was an oboe carrier that sank in 1980. She was almost 300 metres long, and it's believed she sank within seconds rather than minutes. What about another scenario? You've slightly more time and you can send a distress. You give your last known position, but that was taken 6 minutes previously. In that time, your ship could easily have travelled a couple of miles. In both scenarios, one piece of equipment could give rescuers vital information, the EPIRB. An EPIRB is an emergency position indicating radio beacon. They're standard equipment on vessels nowadays, and they can even be carried by individuals in kayaks or if you're a hiker or something. Today though, we'll take a look at a standard maritime EPIRB that would be carried on a ship. This is a typical example. You've got the main body of the EPIRB, which is waterproof and able to float. You have a switch for manual activation and sensors on the bottom for automatic activation. And finally you've got the antenna, which needs a clear view of the sky. EPIRBs should be mounted in float-free containers. These basically are just protective housings with a hydrostatic release that will cut the EPIRB free when submerged. In our earlier scenario, should a ship sink before you can send a distress, in theory the EPIRB will float to the surface and automatically activate. That's where those two sensors kick in. All they do is detect if a conductive medium, like seawater, is present. The small amount of current passes between the contacts, tells the EPIRB that it's been submerged and needs to activate. Alternatively, if you have time to carry the unit and take it into your survival craft, then you can activate it manually using the switch. Either way, you now have an EPIRB desperately trying to tell the outside world that help is needed. To do that, it needs a clear view of the sky. It needs to get a direct line of contact with any one of the satellites in the COSPAS-SARSAT system. These are a network of satellites orbiting the Earth designed to pick up these distress signals. Every EPIRB will transmit its own identity to the satellite system. In addition to that, modern ones also transmit their GPS location, so they can be immediately found. Of course, even if you have an older model that is not GPS enabled, the satellite can still find you. What it does is measure the Doppler shift in the frequency of the transmission to work out your position. Basically, if the signal has a higher frequency than expected, the satellite is moving towards the transmitter, and if it has a lower frequency, the satellite is moving away. The maths is complex, but that frequency shift is enough to give a location. Of course, GPS-enabled beacons bypass all of that and just tell the satellite where they are. So, now a satellite knows the identity and position of a distress beacon that's been activated. It's still not much to go on, but it's enough to get help mobilised. Satellites send the distress down to monitoring stations, where it's then passed on to regional control centres. These centres have access to a database of all EPIRBs that have been registered. This gives them information about the vessel that the EPIRB's registered to, so that they can plan their rescue appropriately. For example, if a centre detects an activation of an EPIRB from a yacht, they will know the colour of the hull, the size of the yacht, and things like that. All vital information when an aircraft is sent to search. Likewise, if the centre detects an activation of an EPIRB from a commercial vessel, they'll be able to attempt contact using radio or satellite communications. They may then contact the vessel's owners, who can provide passenger and crew manifests, or details of the cargo that's carried. Again, all vital information when planning a rescue. The Rescue Coordination Centre can then commit assets, be it passing ships or aircraft, or dedicated search and rescue services. They will have an accurate position, and details of who needs rescuing, all of which increase the chances of a successful rescue. So, what can you do to make sure this essential piece of kit brings you help when you need it? Well, as we mentioned, it needs to be mounted in a clear space so that it can float free should your vessel sink rapidly. If you take it into a lifeboat, make sure you activate it manually and follow the instructions on the unit itself. It will probably say to tether it to your life raft, but to then leave the device itself floating in the sea. Either way, make sure it has a clear line of sight to the sky. You don't want anything to hinder the path of the signal from the unit to the satellite. And finally, make sure it's registered. Giving rescue authorities the details of your vessel can make all the difference. Give the folks in the helicopter the best chance of finding you. And that brings us to the end of today's video. Hopefully you found it interesting and maybe learned something new. For more videos like this every other Friday, be sure to subscribe right here on the channel. Until next time, thank you for watching, and goodbye.
Mr. Johnson likes this SEMrush data.
Just explain it to him like he's a child.
In this video, we're going to look at how you could use a VHF in an emergency situation. First off though, I'd like to take a moment to thank Fire Aid Academy for making this video possible. So, let's consider this surprisingly common scenario. For whatever reason, you find yourself on a vessel and the appropriately qualified radio operator is incapacitated. Maybe you're on a family sailing trip and the skipper falls unconscious, or maybe you're on a commercial ship and you take to a life raft but the normal radio operator didn't make it. Legally, of course, to use a VHF you need to have completed a course and be appropriately qualified, but when it comes to a life and death situation, preservation of life should always take priority. In the life raft situation, hopefully you grabbed a handheld radio on your way to the raft. It's not actually standard equipment, but along with EPIRBs and SARTs, it's one of those things that you should always grab if you have a chance. This is a typical handheld VHF with the main body and a flexible aerial that sticks out the top. On this particular example, we've got a combined on-off switch and volume control at the top. You just turn it and it will click on and increase the volume all the way to the top. On the front, you've got the main screen, probably giving you loads of information. We only really care about the channel number today, which in this case is channel 16. Below the screen are the main buttons. There are any number of buttons depending on your exact model, but the important ones today are these two, which increase and decrease the channel number, and this one, which automatically sets the radio up for the distress channel. Notice how it has the number 16 written on it. Channel 16 is the channel for distress. It's also for calling, but that will be covered in your actual radio course. The final button is the PTT, or push to talk button. When you push this, your radio starts transmitting. You would speak into the microphone, just here, when you transmit, and you listen for a response coming out of the speaker. Now, the big thing to remember with VHF is that there can only be one transmission at a time. If you push to talk, your radio starts transmitting and all other radios in range on the same channel will hear what you say. If someone else then tries to transmit on the same channel, it's not going to work. Both will transmit, but they're going to cut across each other and no one's going to hear what either transmission is saying. That's where you hear the movies and that word over. Over is a code word on the radio indicating that you've finished speaking and you're releasing your push to talk button. It tells everyone else the channel is clear and you're ready to receive a reply. If someone's talking to you, wait until you hear the word over before you start to transmit your response. So you're in your raft with your radio on and you want to attract attention. You're already listening on channel 16 as we covered that, but now you want to get help. You want to make a radio broadcast. If you really want to get the attention of everyone listening, as you would in an emergency, you start transmitting on channel 16, beginning your broadcast with the emergency word Mayday. Emphasize it too, repeat it 3 times slowly and clearly. Mayday, Mayday, Mayday. As all other sets will have a qualified operator, that word Mayday kicks in certain actions. Stations are going to start logging the radio traffic and all non-emergency traffic on the channel will stop. Remember what we said about channels only carrying one transmission at a time? No one wants to cut off an emergency broadcast. I'm not going to cover the precise message you should transmit, as this video isn't a substitute for the course. Maybe broadcast you don't know how to use the radio and then just hope the Coast Guard can help. Mayday, Mayday, Mayday. I'm sinking. I've never used a radio before and I need help. In theory, the Coast Guard will answer and can then guide you from there. Again though, I can't emphasise enough the importance of getting qualified. Consider the training a part of your emergency equipment. You'll learn that you need to transmit your identity, your position, the nature of your distress, what help you need, the number of persons on board, and any other additional information the rescuers might want. You're never going to remember all that from this video though, so just say you want help. Depending on your exact location, you could find that no one responds. VHF does have a limited range, entirely dependent on the height of the antenna. Your handheld radio at the surface of the water, as it would be in a life raft, typically only has a range of a couple of miles. A yacht with an antenna at the top of the mast can increase that range to 20-30 miles, and a ship or shore station with a massive antenna can transmit significantly further still. In some spots you may be able to hear the Coast Guard clearly, and they would have no idea about your transmission from your handheld radio. To get the increase from range, you want to use your vessel's fixed VHF set if you have one. They operate in basically the same way as the handheld, but they're more powerful and they're likely to have the additional feature of DSC. DSC, or Digital Selective Calling, is a bit like a paging system for radio. Each station has an MMSI number, which is the equivalent of its phone number. You can page any individual set, or you can just page all sets in range. The automatic distress button will automatically page every set in range, so it's usually hidden behind a cover to prevent accidental transmission. When you activate it, by lifting the cover and pressing and holding the button most likely, it's going to send an alert to DSC radios in range, sounding an alarm on those units. It'll automatically give the receivers information like your identity, maybe even your position and things, as well as telling them a distress transmission is coming. You'd then transmit the verbal distress, just as you would with a handheld radio. So, as it all does sound quite complicated, why bother with VHF at all? Why not just dial 999 or 911 from a telephone? Well, the critical thing about VHF is that it's designed for the marine environment. All vessels need to be equipped with VHF, so if the Coast Guard doesn't respond, then a passing ship might. Not only that, but VHF is so much easier to locate as well. The Coast Guard and search and rescue craft can actually triangulate a VHF transmission. It's most commonly used when people make false calls, but it can also be used to locate a vessel in distress if they don't know their position. We've only briefly touched on VHF today, looking at how it could be used in a distress situation. Of course, it's also used for a whole range of things like VTS, port communications, shipping information and weather updates. For all that though, you definitely do need to become a qualified operator. And that brings us to the end of today's video. Again, a massive thank you because this video has been produced in partnership with Fire Aid Academy, who offer a range of professional maritime courses, including sea survival, firefighting, medical and security courses. Fire Aid have worked within the industry since 1991. You can visit their website to see the full range of courses available at www.fireaid.com. Until next time, thank you for watching and goodbye.
Okay, that's the end of my presentation for this sharing session. Thank you to participate and your kind attention in my presentation.
Kita telah sampai ke sesi Q&A. Para peserta dan pensyarah boleh bertanyakan soalan di ruangan chat atau bertanya secara langsung dengan membuka button unmute anda.
Okay, I got one question from Bob. Does the EPID, I think it's EPIRB, EPIRB, and SAT equipment can function under extreme weather condition like thunderstorm, heavy rain, and etc. Okay, yes, it is designed to face the extreme weather condition, and also for the VHF FM GMDSSS is certified by ATEX. It means that it can function under extreme weather. So it can be used during extreme weather like heavy raining, thunderstorm, and if you notice that in the video, all the equipment is can sustain to 96 hours after deployment. After switch on, it can sustain until 96 hours. 96 hours is the compliance of the SOLAS standard. We need to comply to the SOLAS standard during at sea, during we are at sea for offshore.
So I have a question. Untuk monitoring the CCTV, adakah monitoring akan dilakukan di CCP saja atau boleh disambungkan terus ke onshore client?
Boleh terus daripada onshore client office. Sebab kita connect to the client network, okay? The client got the approval to, because it's their platform, so they can monitor what happened to the offshore condition, what happened at the wellhead, at the CPP also as well. It's just a network configuration, just only for just for configuration method only. How we configure the switch to switching. The monitoring is from where? From onshore or from the platform. We can do based on the client requirement. If client wants to monitor from onshore, we can do that, and from offshore also we can do that. Or of both concurrently also we can configure to monitor the wellhead platform in real time. Okay, real time.
Okay, thank you.
Welcome. For me, the telecommunication for offshore is very interesting system. Not like others system. And also not all people know that telecommunication, we covered this system in offshore. Not all people know. And I find the telecommunication at offshore is very interesting to me. And very glad to be as a telecom engineer. It's different from the telecommunication in onshore. In mainland, they only use for the communication link to extend your mobile phone communication, and it's very limited. But for offshore, is a widely used, not just for communication, but just and also for monitoring, for emergency use, and so on.
Saya buka lagi sebarang soalan. Jika ada sebarang soalan, boleh nyatakan di ruangan chat ataupun buka button unmute anda.
Okay, soalan yang kedua daripada saya adalah, bagi beacon signal ni, boleh ke ia berkomunikasi dengan satelit?
Beacon signal, beacon yang mana satu? Radar beacon, record.
Ya betul, radar beacon.
Okay, radar beacon, okay, what is record is use Morse code, okay. Kalau kita belajar Morse code tu, dia transmitting normally untuk radar saja. Radar, so dekat radar ship, kita boleh nampak Morse code signal. Okay, satellite we use frequency, gigahertz frequency is a different type of method of communication. So the answer is cannot. The record will be show on the radar, ship radar only.
Alright, good.
Okay, Puan Haniza, I've got one question for you. From Bob, it says, does the EPIRB can function properly if it sinks under the water, or there is very high tide wave, and also if any sea creature knocks the EPIRB badly, does the function of the EPIRB can get disrupted?
Okay, from the previous video, EPIRB will not sink. It will float. It will floated at sea because it is designed as such way to float itself for self-floating. So the EPIRB will be self-floating, and then when it reach the water, we touch with water, it will automatically initiate the signal to the emergency response SARS to rescue the personnel. Okay. If any sea creature not the EPIRB badly use the function, EPIRB can get disrupted if the EPIRB broken, and then it cannot send the signal. But like I said, EPIRB is only can initiate the signal within the 96 hours only. So after that, there is no if there no rescue, and then should be no survival. Okay.
Thank you, Puan Haniza.
Out of box question. Very good, very good.
Ada lagi sebarang soalan ke? Boleh nyatakan di ruangan chat.
Senang ke susah telekom dekat offshore? Siapa boleh jawab? Yelah, yeah, it takes time to learn, but it's a very interesting system for offshore telecommunication. To me, it's very interesting. Can survive.
Puan Haniza, I've got another question from Bob too. He says, does the EPID and SAR can survive tsunami?
Okay, I got question. Does life raft can survive the tsunami? I think tsunami happen at the coast, okay, at near the pantai, but at the sea level, it will be a normal, or the tides will be life raft can still floated at the tides, if you're high tide or low tide, so it can survive this within the tsunami. The equipment itself can survive, but the survivor, the personnel, the survivor might not survive during the tsunami. But the last point of the EPIRB maybe recognized by the SARS team, and then the search and rescue team will go to the last point of the EPIRB to rescue the personnel. Okay, Bob? Okay, welcome.
Saya buka lagi satu soalan terakhir untuk jika ada persoalan boleh nyatakan di ruangan chat. Nampaknya tiada sebarang soalan. Oleh itu, saya nak memberi sedikit makluman. Diminta semua peserta untuk mengisi link keberkesanan kursus dan menjawab soalan post-test melalui pautan yang telah dipost di ruangan chat. Sijil hanya akan diberi sekiranya soalan pre-test dan post-test telah dilengkapkan oleh peserta. Okay, Puan Haniza, I've got final question from Bob too. He says that is these things one function in Bermuda Triangle are right?
What happened with Bermuda Triangle? I think is a myth to me. I mean, Bob say that everything that Bermuda Triangle we will not receive signal, frequency signal, right? But for the function of the EPIRB, AAS side and GMSS is normally can be used on the in the sea, on sea. Okay. The Bermuda Triangle, I think is a myth. Is only a myth to me.
Okay, thank you, madam.
Untuk makluman semua, video webinar pada hari ini akan dimuat naik ke YouTube rasmi PSIS. Terima kasih.
Makluman kali terakhir, diminta semua peserta untuk mengisi link keberkesanan khusus dan menjawab soalan post-test melalui pautan yang telah dipost di ruangan chat. Sijil hanya akan diberi sekiranya soalan pre-test dan post-test telah dilengkapkan oleh peserta.
Thank you to Puan Haniza for the talk and insight. As the saying goes, to every beginning there is an ending. And now, the webinar has come to its end. Once again, I thank you everyone for gracing our webinar with your presence. We truly appreciate it. On behalf of the organizing committee, I would like to apologize if we have done any mistake throughout the event. I end my duty as the moderators for today. Thank you very much.
Okay, fine.
Saya mohon untuk semua peserta membuka kamera masing-masing dan menggunakan virtual background untuk sesi bergambar. Dah bersedia ke? Okay, get ready. Smile. 1, 2, 3. One more. Ready. 1, 2, 3. Freestyle. 1, 2, 3. Saya mewakili pihak penganjur Saya mewakili pihak penganjur mengucapkan setinggi-tinggi penghargaan kepada Puan Hanizah kerana memberikan input yang bernas kepada kami. Penghargaan juga kepada Teknologis Nizam di atas kesudian merasmikan webinar ini. Kami juga ingin memohon kemaafan di atas kekurangan dan keterlanjuran di sepanjang sesi webinar ini. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.